озвучить вот регламент временной, да?
Да, я тогда начну. Hello,
Слушай, Вань, говорит же Алексей, надо следовать регламенту жестко, попросил.
Что?
10:00 дождемся.
В 10:00 начало доклада.
Начало доклада 10:00.
Все понятно. Извините, я все прослушал.
Hello, dear colleagues. We continue section which called Information and Computer Science Technology. My name is Dr. Ivan Blikanov. The session is chaired by Professor Alexander Krylatov and I. The moderator of this section is Alexey Yeremin, and the scientific secretary of this section is Dr. Vanessa Petrosyan. Today we have 27 speakers who will present their talks. All presentations are in English. Not more than 12 minutes are given for every presentation. 2 minutes before the end of this time, I and or my colleague will inform you about this. After that, there will be 3 minutes for questions. During the presentation, the audience will be muted. After the presentation, you can unmute yourself and ask questions. In addition, questions can be asked in the chat, and I or my colleagues will voice them. The same for the chat of YouTube, where the live broadcast goes. The first presentation is
Okay, I can introduce. The first presentation concerns analysis of tourism income data of Xi'an, and the presenter is by Huizhen. Are you here?
Yes.
Okay, you're welcome. Please, you can start.
Share screen, please.
Hello, professors. My name is Bai Huizhen from Yan University. Next, I would like to introduce this paper. The title of which is the Analysis of Xi'an Tourism Income Data Based on Time Series Method. This paper mainly analyzes the situation of tourism income in Xi'an from 2004 to 2007, and analyzes the situation of tourism income in Xi'an according to a simple sliding average method in time series analysis. The result is that Xi'an tourism shopping income decreases, which will lead to the decline of Xi'an people living standard and affect the development of Xi'an. This paper first introduces the concept of time series analysis and the method of simple sliding average method. They illustrates the tourism income from 2004 to 2007 in Xi'an, and they establishes a model. The prediction results of tourism income in 2008 obtained by time series method are analyzed. Finally, in view of the idea of raising tourism income in Xi'an, some reasonable suggestions are given. This paper mainly has 4 parts. The first part is the understanding of time series. The second part is analysis of tourism income in Xi'an city. by time series. The third part is analytical result. The fourth part is facilitability suggests the tourism income in Xi'an. The other study of time series. There are 4 main points. First, time series implications. Second, main classification and variable characteristics. Third, commonly used analytical methods. Fourth, method of deterministic time series analysis. Time series analysis. Time series implications. Time series refers to the sequence formed by arranging the various of a certain phenomenon at a certain statistical index in different times. In different times according to the time sequence. Time series method is a quantitative prediction method, also known as simple extension method. Time series analysis is a statistical method for dynamic data processing based on stochastic process theory and mathematical statistics method. The statistical law of random data sequence is studied to solve practical problems. Main classification. First, absolute time series. Second, relative number time series. A time series in which a series of relative numbers are arranged in chronological order. Third, average time series. Time series in chronological order by a series of similar averages. Variable characteristics. First is instability. Time series variables cannot show a long-time trend and eventually tend a constant or linear function. Second, variations in the amplitude of fluctuations over time. Variance of a time series variable varies with time. Third, stationary time series. The statistical characteristics of a time series will not change with time. Commonly used analytical method. There are 2 commonly used analytical methods. First, indicator analysis. Through the analysis of time and sequence, the development and change of the phenomenon are revealed. Second, composition factor analysis. Through the decomposition and analysis of the factors affecting the time series, the law of the evolution of the phenomenon with time is revealed. Method of deterministic time series analysis. Time series prediction technology is to predict the targets of time series processing to study its changing trend. A time series is often superimposed or coupled in the following types of variation. First, changes in long-term trends. Second, seasonal changes. Third, cycle change. Fourth, irregular changes. Part 2, analysis of tourism income in Xi'an City by time series. There are 2 main points. First, modeling. Second, analysis of tourism income in Xi'an by model. Modeling, the model of simple sliding average method. The formula for calculating the average value of a simple movement is this formula. When the basic trait of the purpose of prediction is to fluctuate up and down at a certain level, the prediction model can be established by a simple moving average method. Its prediction standard area is this formula. Effect method to select the best value is to compare the prediction errors of several question types, and the minimum prediction standard error is good. Analysis of tourism income in Xi'an by model. N is equal to 2, N is equal to 3. Prediction formulas Y1 and Y2. First, substitute the data user table and calculate the long distance transportation revenue. In 2008 forecast value, and N is equal to 2. Prediction value is 2,864. The standard error of prediction is 2,390, and N is equal to 3. Prediction value is 12,680. The standard error of prediction is 1,798. The standard error of prediction is small when N is equal to 3, so take N is equal to 3. Long distance transportation revenue forecast for 2008 is 12,680. Using the same method, the income forecast of shopping income, catering accommodation income, and other income in 2008 is obtained. Shopping income projected for 2008 is 60,556. Projected income from catering accommodation in 2008 is 9,411. Other income predicted for 2008 is 12,132. Part 3. Analytical result. Analytical result. According to the data in the table, the main source of Xi'an tourism income is shopping income, and the forecast results show that Xi'an tourism shopping income will decline in 2008. The main reason is that the income of long distance transportation, catering and accommodation and other income is reduced. As for feasibility suggestions of tourism income in Xi'an, there are 6 main suggestions. First, must be distinctive. If not, there are characteristics. It is difficult to attract tourists. Second, complete security system. Do not generalize all the internet or learn from other systems. Should consider from their own characteristics of tourism areas, how to ensure safety, really let tourists feel safe. Third, construction of service area. Each tourist destination will have a corresponding service area, but how to make tourists feel satisfied is very important. Fourth, tour guides in the tourist area must have enthusiasm and patience. In the introduction of scenic spots must have their own characteristics. Do not join only talk. Fifth, feedback from tourists. Be sure to communicate with tourists in a hurry, not just send a form to tourists for them to fill in. Sixth, characteristic culture, food, and entertainment facilities. That's all for my presentation. Thank you for listening.
Okay, thank you very much. It was an interesting presentation. I guess we don't have time for questions.
Yes.
Yeah, sorry.
Maybe
Okay,
only
next presentation is comparative study of various age detection operator, and the presenter is Ming Bai and Shuai Li. Can you hear us?
Yes.
No, I mean Ming Bai.
Liz
Bai
was
Ming.
here, I think.
Yeah, he is here.
Hello, Professor.
Thank you.
Hello, hello.
Wait a moment. Minute.
Yes, great.
Bai.
Hello, Professor.
Bai Husen, please stop share screen.
I stopped it. Okay. Bai Ming, you can share your screen and present.
Okay. Hello, Professor. Can you?
Yeah, we can see it. You can start.
Okay. Good morning, professors. My name is Bai Ming from Yang University. Next, I will introduce to you the paper of Li Sha and me, comparative study of vigorous age detection operator. How to get the guidance of professors. The age of an image is one of the most physical features of the image, and it is the most significant part of the local intensity change of the image. The so-called age refers to the connection of pixels with stepwise or roof-like changes in the gray level of the surrounding pixels. In essence, image age is a reflection of this continuity of local image characteristics. Age detection is a key step in image pre-processing. The detection results have a direct impact on feature extraction and image processing in the later stage. Our paper mainly compares and analyzes super operator, log operator, and canny operator, and compares and evaluates their performance characteristics through experiments, so as to give full play to their advantage and provide an improvement basis for the study of new algorithms. Next, I will introduce the principle of age detection. The age of an image has two characteristics of direction and amplitude. Age detection is a measurement and location of grayscale change. Image age detection can be generally divided into 4 steps: flattening, enhancement, detection, and processing. Flattening age detection algorithms are mainly based on the first and second derivatives of image intensity, but the calculation of derivatives is very sensitive to noise, so it is necessary to use flatters to improve the performance of age detectors related to noise. Enhancement. The enhancement algorithm can highlight points where the neighborhood or local strength values have significantly changed. Detection. judged according to the gradient amplitude threshold value. Position. If an application requires an edge position, the position of the edge can be estimated in sub-pixel resolution, and the aggregation of the edge can also be estimated. Next, I will introduce to you the three operators studied in this paper. Sobel operator. Sobel is an edge detection operator based on the first derivative. First, the image is weighted and averaged, and then differentiated. The first potential derivative can be replaced by difference, and finally, the gradient value is obtained. Log operator. Log detection operator is a second derivative edge detector operator, which combines the advantages of Laplace detection operator and Gauss flatter. Basic idea: Gauss operator is used to smooth the original image and reduce the noise. Then Laplace operator is used to convert the edge points into zero intersection points. And then the second derivative zero intersection points are used to realize edge detection. Canny operator. The Canny operator studies the characteristics of the optimal edge detector: high accuracy, high precision, and single pixel width. In view of these three characteristics, Canny proposed three optimal criteria for the first order differential filter for edge detection: the maximum single-to-noise ratio criterion, the position accuracy criterion, and the single edge response criterion. The specific steps of Canny operator edge detection are as follows. Step 1, use Gauss flatter to flatter and denoise the image. Step 2, use the finite difference of the first order potential derivative to calculate the amplitude and the direction of the flatted image gradients. Step 3, adopt no maximum separation for gradient amplitude. Step 4, double threshold algorithm is used to detect and connect edges. Now, let me introduce to you the results of our experiment. The results in Figure 1 show that the Sobel edge detection operator can only detect the contour of the image with merely discontinuity points, poor edge continuity, and potential detail information lost. Log operator has better edge continuity than Sobel operator, and the details are highlighted. Compared with Sobel operator, log operator has a better detection effect. The edge image obtained by Canny operator is more complex, and the detection effect of Canny operator is better than the previous two. The results in Figure 2 and Figure 3 show that the Sobel operator has good anti-noise performance, but the detection accuracy is not high, and there are many discontinuity points, and the image is blurred. Log operator has good edge integrity, but it is sensitive to Gauss noise and salt and pepper noise. Canny operator has high precision of edge location and good continuity, but it is easy to smooth out some edge information. Through the above experiment, the advantages and the disadvantages of the three operators are analyzed, and it is concluded that Canny operator is the better one among the three edge detection algorithms, but it is not the best one either. In the actual use, it is difficult to avoid the inclusion of noise, so it is necessary to choose the appropriate operator according to different requirements. Sobel operator is suitable for gray gradient and noisy images. The log operator often appears double edge pixel boundary and is sensitive to noise, so it is suitable for edge detection of low noise or no noise images. Canny operator is not easy to disturb by salt and pepper noise. and can detect the real weak edge with high position accuracy, but it is greatly affected by ghost noise. Most of the time, a single operator cannot meet the requirements, and multiple methods need to be integrated. The above is all the content of our paper. I hope to get your guidance. Thanks for listening.
Thank you very much for your report. Dr. Plekanov, do you have any questions?
Sorry. Did you test your approach on real data?
Yeah. This picture. It's my experiment outcome.
Okay, and only one picture.
It's called I don't in my PPT.
Maybe exist special test collection of images for testing. Did you review it?
Our experiment many compiled and analyzed the three operators use the MATLAB. Our experiment many use MATLAB. This outcome is these pictures.
Mm-hmm.
It's our experiment.
Okay, thank you.
Okay, thank you. Thank you, Professor Guidance.
Hello. Can you tell? Do you have any? Have you used any benchmark to test your results, or have you compared your results with the other existing approaches? Maybe I have missed it in the presentation.
You can say the figure one, the solver edge detection operator. It's with many discontinuity points. The log edge detection operator is continuity points. The kernel edge detection operator looks like better. The left original grayscale. This picture is our original picture.
Okay. Thank you very much. I think very interesting. Can you tell which algorithms you want to plan to compare with in future? So you want to develop the approach, right? So you want to understand you need to understand what are the state of art of algorithms and approaches in your direction, and then you need to compare them to your approach in order to understand for which kind of problem your approach is better or not. So maybe it's a question or maybe suggestion.
Okay.
And how to
maybe
measure
a recommendation.
Yeah, how to measure your algorithm? You show the pictures, but how to measure? What is the KPI? For example, for forecasting, the KPI is, for example, MAIA metric. But what is the KPI in your task? How to measure in number?
I think that our
quality measure.
Measure we can use we can use many pictures in MATLAB. We can make experiments to measure canny operator.
Okay, I think we don't have any time.
Okay.
Yes.
Thank you.
Thank you for interesting presentation.
Yeah, interesting presentation. Okay. Alex, I'm afraid I can't see next presenter, Mr. B or by, I think B. The next presentation is controllability of multi-agent system with clusters. Any presenter? I can't see the presenter in the list of participants in Zoom.
And he's making 2 talks.
Yes.
That's kind of tricky situation. So we have to decide if we proceed to the talkers scheduled for 11 or if we wait.
I guess the first strategy is much better.
Right, this way we have bigger pause in the middle of the section, right?
Colleagues, please fix who absent today, because this information need to.
Yes, of course, I fixed.
Okay. Do you know where from these speakers?
I guess from University of Aizu.
It's our university.
I don't think so.
Nothing. It's also not from Yunnan University. We have no such a person in our list from Yunnan University.
Okay, so I think we can ask the next speaker scheduled for 11, Yuan Tu from University of Aizu, to present his talk now.
You mean I define winning actions, this presentation?
Right. Tennis game.
Okay.
And are you guys able to see my screen?
Great.
Thank you. Okay, good morning. And my name is Tu Yuan, and I come from University of Aizu. Today, my presentation will be identifying winning actions in a 3D tennis game with the Monte Carlo tree search. And firstly, I want to talk some background of our motivation. So nowadays, I think sports games are getting popular, and also opponent AI play a really important role in this game. So firstly, we find a game called World of Tennis, which is a 3D tennis game. We use it at our test field. Also, the method we're going to use for building the opponent AI is called Monte Carlo tree search. Firstly, this is our game. During showing the video, I will introduce some basic moves. Oh, sorry. So this is easy, right? Serve and return a ball, return a shot. And then you will notice every time player return the shot, it will like do some recovery movement. it will go back to the middle of the court or somewhere to make it return the ball easier. Yeah, this is basically our court test field. And about the game AI, like as we all know, actually, game AI will always use rule-based AI. It's really common, but this AI requires the implementer know about the game logic very well, and we have to ask the implementer to consider all different game patterns or situation to make AI works. So the disadvantage is really obvious that we're human, we make mistakes, so we can't consider that much about the situations. That's why we want to use some heuristic algorithm to make up this, come over those disadvantage. The good points of those kind of algorithm is it's actually good for the class of decision problems. And it's also good when the problems approximate solutions are sufficient and exact solutions are necessarily computational expensive. So this is the method we're using called the Monte-Carlo tree search, as I mentioned before. There's only 4 steps we need to follow to do the tree search. Firstly, we need to selection, and then expansion, and simulation, and also backpropagation. And then after repeating those steps, then we can make our AI to choose the best decision to make, to choose the best move. Okay, firstly is a tree search. So of course we need to build a tree. And this is how we model in the game tree. So as I showed you before in the video, it's like a tennis court. And from the game, we need to extract those informations. Firstly, we need to know who shoot the ball. So is AI or opponent? And secondly, we need to know our AI's position and also opponent's position. And when people hit the ball, trying to return the shot, where is the target? And also we need to know the shot types. So actually for the positions, we actually can use the coordinates of these players or AI, but like there's so many dots in the court. So we divide the court to 48 squares. So it's easier for us to represent the position of the player or the AI opponent. And this is an example of the tree. Let's say this node tree, root node is our current state, which means the ball is shot by the opponent, and our AI is standing at the square 44, and opponent is standing at 3, and opponent is trying to shoot the ball towards to the target, the square 36, and this ball's shot type is span. After that, we probably expand 2 nodes is like the next possible move of our AI. So our AI will shoot, and it can AI stand this place for sure, and opponent stand this place is also like a specific thing we already decide, but they can shoot to different target, maybe square 15 or square 11, and the type of shot it can also be different. Let's go back to our method. The first step is called selection, and for selection step, we're using UCT, upper confidence tree value, and this UCB1 algorithm equation were used. The calculation is like this. This part is the reward term, and this is a constant to balance this reward, average reward, and this small n. So for selection part, for example, if we're here and we want to select which way to go, then we need to know these 2 parts, UCBI value. If this one is higher, of course, we're going to select this part and then keep going. And then for the expansion step, the game tree is expanded by adding child nodes if the leaf nodes have been explored beyond a certain threshold. So for example, we're trying to find the right path, and let's say we arrived here. This nodes we already visited, let's say 3 times, but our threshold is 2, which means it's more than threshold. So we're gonna expand more nodes from here. And then simulation. Simulation steps actually is actually important. The result of the game from the leaf nodes will be simulated. And the AI needs to judge from the simulation about what moves need to be taken by AI to gain the point. And in our case, we use like more than 10,000 actual game data to extract those informations and trying to simulate the game. There's important information we extract, whether this shot will scoring or not. So if, let's say we're at this end node, a leaf node, and this node said, yes, this shot will score, gain a point, then this search will end it here and then go back to selection. So this way is certain, confirmed. And backpropagation. So as I said, like selection, expansion, and simulation, they're actually repeating all the time. Because at first, you probably only have this part of the tree, and you need to find the best way, which means you need to expand and select again. So after the simulation value of the node, which hasn't been visited enough times, the process goes back to the selection step and repeat until AI is able to make a best decision, to make a best movement to score. And as a result, our AI played a serious game against the coach AI, simple AI. So this simple AI is actually based on the rule-based AI. It's a really easy AI. And we let them fight, yes, and we win 7 games out of 10. So this result actually just show that our AI is able to make rational actions, but still it's a really simple AI. And for the conclusion, like firstly, we're able to perform the modeling the complex game state to build a tree to perform this state, and also we can adapt the MCTS for our game, and we successfully built an AI for the tennis game. So, but still there's a lot of disadvantage. So we think we can improve in these 3 points, increase the simulation's accuracy, like by adding more data to train the AI, and also we can generating more valid nodes that includes more moving patterns in the expansion step. Finally, we can add more useful information for simulation to increase the accuracy. Yes, that's all. And thanks for the attention. If you have any questions, please let me know.
Thank you very much, colleagues. Do you have any questions?
Thank you for presentation for game dev. I have questions. What platform did you use for simulation and testing?
So simulation part, we're trying to extract the game data to JSON file. Like, to be honest, the details I don't really sure that much because my professor provided, and I think in the JSON file there's a lot of details about the game, like when it starts, when it ends, and where did they hit the ball. But we only extract the important parts, like those informations. Is that answered your question?
Are you going to apply your approach on real case, maybe?
Sorry, so am I going to?
Are you going to? Are you planning to apply your approach on real data?
Yes, yes. Those data are real data. Like player played it before and it was recorded, and to a JSON file. But because if you play it, you need to play it so many times, so we can get like 10,000 data. It's like from, I think this game have a lot of players in the market already, so they can get some data from players.
Okay.
I'm not sure if I answered it right. Sorry.
Okay, thank you very much.
Hello. Can I ask a question?
Sure.
Thank you very much. Very interesting presentation. Actually, so I have a bunch of questions. So the first one, as I can see, what you want to define is in some sense an optimal policy, right? So
Yeah.
you want a rule-based approach, right? So why you did not try the classical reinforcement learning algorithms such as DDQN or DDPG? It's a first question. Second is that maybe I understand that you don't like the complexity of the reinforcement learning. That's why you wanted to apply rule-based. So in the rule-based, what kind of why you use a random search class of the algorithms to define the parameters of the decision tree? Why you don't use any other kind of algorithms such as they are the winners for the combinatorial optimization competitions from 2015. The algorithm is called CIMAP-NAS, and also tree linkage, if I'm not mistaken, tree linkage GA algorithm or things like this. So can you elaborate on this? How you really apply a rule-based approach in such a straightforward way? It's very interesting. I'm very interested to understand.
Okay, thank you for your question. And firstly, I think you said we're using rule-based AI, but actually, I think the rule-based AI is already set in the game, and we're trying not using that. But it's a really good question that why we're using this algorithm, but not other more complex or like more advanced, because I'm ashamed to say that, but we're undergraduate students, and we have a really limited knowledge for now. So I just thought this Mountain Carlyle algorithm, it's kind of fun, so we just want to take a try. And I think what you've mentioned is really interesting. Like, please just provide me more information so we can work on that. And thanks for the information. Thanks for the question.
No. Actually, no need to say sorry, because if you there is a very good not a message. I cannot tell you in English. I'm sorry, I cannot explain. So
may I mention something in addition to this answer, because just I'm a little bit attached to this project as well, though I'm not completely in this project, but probably doesn't know everything really. But one aspect is that the goal of training this AI for this World of Tennis project is not to implement an optimal strategy, because no one would like to play against ideal computers. It is not interesting at all. And the goal is to simulate a kind of believable behavior of AI, so that AI acts like more or less real players. So not as an optimal strategy, but a strategy allowing people have some kind of entertainment from the game, not simply like achieving the highest optimal level of AI player. And another aspect is that these AI players are trained just, it probably sounds strange, but just to substitute real players when they are absent for some reasons, in order not to spoil statistics of their game playing, and that's quite interesting thing. So as soon as you sleep and you couldn't play, your AI agent will play instead of you, implementing some style of your playing, some kind of strength of your playing, just to keep your record alive. So these are a couple of aspects. So we don't have Maxime Mozgovoi here, unfortunately, and probably he would explain even much better than myself, but just in addition. Sorry to interrupt you.
Thank you. Thank you
So
very
my
much.
name is Evgeny Pishkin. I'm from the University of ISO, but just not in this contribution.
Okay, thank you very much, Professor, because the next presentation is presentation of Zik, Yang, Tang, and you. So
yes,
we can follow.
Definitely.
Thank you very much.
Thank you.
Thank you.
Launch our presentation.
Perhaps someone should work on the AI that can substitute the missing speakers, so not to spoil.
Unfortunately.
So, do you see our presentation right now?
Yes, we can see it.
Okay, so
yes.
Okay. R1. We are from the University of ISO, and appreciate the opportunity to do this today. As the title indicates, I would like to introduce soft planning and realizing the process of system design, modeling, and project conceptual core. And first of all, I would like to introduce our research question. I'm going to introduce the concept of soft planning. It has some characteristics, not particularly certain, maybe actively with some suitable but probably unplanned situation to place, and in principle may not be implemented at all. And in our article, we realized the process of system design, modeling, and project conceptual core. And the use case maybe have some types, maybe like the type C. In the left picture, we can see that it's all of snow. There are many trees and no flowers. And this soft planning in a good season, you can see the picture like the red one. So it's a very good season, and the soft planning will give you some reminder or notification. And there are other use cases about shopping. It's like the sales realizing that something is missing and give you some reminder. And as we know, there are already many planning right now. The current mainstream planning is as follows: the time and organizational planning, project scheduling and management, and event-based activity planning, travel planning, and the usual constraints of them are the time, budget, location, and multiply user coordination. And our previous paper punished the conference mentioned the concept of system planning. And we have considered the relationship between the client and the user and believe that the notification is a problem that must be seriously considered to achieve soft planning. Notification is very important. And then the diagram shows the revised model introducing major concepts which are necessary to understand how the planning scenarios appear. And as a conceptual core of the whole project, the common sense ontology is linked to domain specific ontologies and expected scenarios to be implemented in the system. You can see that there are some relationship between the user, the reminder, notification system, and
And the diagram in the left is the subject domain apology, and the right one is the use case. Diagram is the use case. This use case is we design a prototype which is the blue one. The blue part is where we implemented. It's a prototype based on the geographic information. You can see we use the location to create a reminder, and the user will get some information in a suitable situation. And the next diagram shows some more insights to our understanding of the links between the scope and the major properties that have to be taken into the consideration while implementing support for managing user-defined reminders and related notifications. You can see that the notification and two things that are not the same. And the system superstate setting and configuring a reminder. It describes major events and action necessary to support the process of creating a reminder and working with a list of active and achieved reminders and saving and deleting reminders. There is also the templates. And the system superstate working with issue notifications. Notifications that describes the major events and actions that may be necessary at the moment. When a notification is issued, after opening the reminder referred as issued notification, the user should be able to forget the reminder, archive, keep active, or reconfigure it. Thus, the system may trigger to the superstate setting and configuring a reminder. And we had a prototype with the Android application with Jotens. Jotens is the treatment when a person enters some area, the application should display a notification suggesting the connected preferred activity. But with the Jotens, the prototype, there are some questions we should consider more, because, for example, the transportation and waiting time and landscape characteristics and some other parameters should be considered. And other discussion and future work, as it showed, using program the reminder together with the reasoning engine may be helpful for getting some more information about software plan for activities. And the identification of possible useful scenarios of user collaboration using software and resolving geofence usage and identification issues and integration of time scheduler and activity organizers, and paying attention to minimizing annoying and unnecessary notifications and preventing of never and reminders. And thank you for listening. Any question?
Thank you very much. Very interesting. Dr. Blekanov and Dr. Petrosyan, do you have questions?
Sorry. Did you test? How did you test your approach? Maybe you create a real situation for testing. Did you apply for did you review anything methods maybe based on using a neural network?
So not yet, so just I have to say one nice thing. Just as probably you know, we are just in the beginning of an academic year here in Japan, and the academic year just started, and Tan-san just entered our graduate school. So it's like 5 days or like 9 days as a master student, and still I pushed him to start work on this project even before he entered the master school, so in very like in an uncertain situation. And so that's why we still have like very proof of concept prototype, which rather is used just to detect issues rather than to resolve issues. And our probably major goal was to present the concept itself, what a soft planning is, because it is rather like new term, and we are trying to describe the situations very common for people when we don't plan something in advance exactly, when we don't know the time, when we don't know why it is necessary, but we want not to forget about like buying a new bottle of cognac because your old is empty as soon as you are in a relevant shop, but it is not like obligatory. It is not necessary right now, but when there is a good case, or if you travel somewhere and see like potentially beautiful landscape, but unfortunately not quite nice right now because of rain or because of bad season and so on, you could probably be reminded like a little bit later when you travel again in the same area or adjacent area, and receive a reminder. Or sometimes ago you said that trees could be very beautiful. Now they are beautiful. What about looking at them right now? So these are like scenarios we try to model, but like at the conceptual level right now. So no enough experiments right now, but
okay,
it's quite nice. Yes.
I think that you can emulate data. For example, you can use data from a social network. You can crawl the data, crawl, maybe collect different place and collect a publication of user which contain not only text information but of course video information, picture, and apply social network analysis method for testing maybe your system in a real case.
I agree. So just Tan-san, it's up to you.
Okay. Thank you. Thank you for your presentation.
3 years more in the graduate school.
Interesting, very interesting.
Okay, thank you very much. It was very interesting. The next presentation is behavior similarity between human players and building AI characters in Universal Fighting Engine. I see Dr. Mozgovoi here.
Hello, can you see it?
Okay. Yeah, we can see the screen, so you can start. Thank you.
Okay, this is Kaori Yuda, and I'm going to talk about the behavior similarity between human players and the built-in AI characters in Universal Fighting Engine. This is team project of 6 students, and thanks to our professor, Maxim Zvopoy. Hold on, I have a problem. Sorry, let me share screen again. Okay, sorry. And let me start with motivation. The reason why we choose to research on game is, for one thing, it is always visualized, and they have rules. So to develop artificial intelligence, it is easy to show to people, and it sometimes make a big impact on a lot of industries people. And to learn behavior similarity, our focus is creating human-like AI. And to do that, we have to know what is difference with current AI or like current built rule-based AI. And the reason we choose fighting game is the popularity. We have popular fighting game as Super Smash Brothers or Mortal Kombat, and which is played over worldwide. And because of popularity, maybe it is easier to get focus. And let me talk about method. And firstly, our platform, we choose to work on universal fighting engine. This is a framework on Unity, and we can customize actions like freely with the limitations or some cool actions like fireball or jumps or something like that. And universal fighting engine also include fuzzy AI. It is rule-based, so they choose action depends on their environment situations. And it also can modify the level by time between decisions, time between actions, rule compliance, aggressiveness, and the combo efficiency. And we have 5 levels as follows. So our method, cosine similarity, let me explain with simple 2 dimensions. X-axis is punch and Y-axis is kick. Of course, in real, our experiment is not only about 2 actions, but just to make it easy. And we have 3 points as C1, C2, C3. And for C1, there's 0 punch and 2 kicks. And for C2, there's 3 punches and 2 kicks. And for C3, there's 2 punches and 0 kick. And with other calculation called Euclidean distance, it is simply measured by the distance. But the problem is C1 and C3 here is completely different move. C1 play kick and C3 play punch. But in this test, C1 and C3 is different. Is 1, 2, 3, 4 and 1, 2. And the C1 to C3 is C2 is 1, 2, 3 and 1, 2. And it means C1 to C3 is similar than C1 to C2, which is not ideal for our experiment. And this is formula of Euclidean distance. And for our research, we use cosine similarity analysis. And to do that, for cosine similarity analysis, we compare the line angle with lines between the origin to behavior points. And C1 to C2, let's say theta 1. And C1 to C3, let's say theta 2. And then in this case, it shows the similarity is higher with C1, C2 than C1, C3. For cosine similarity, the 90 degree will be 0 and 0 degree will be 1. And so the smaller degree will be higher similarity. And this is a formula of similarity analysis. For the actions, we have about 30 elements. It's not only about kick and punches, but we have three major elements, as a current state, current substate, and the current basic move. It is defined by universal fighting engine, and it includes action as stand, jump down, or resting, blocking, or idle move forward. This is the result. And in our test, we have 12 games like this. And in this cluster diagram, it shows the similarity between match opponent. And the lowest point is 0.18, and the highest point is 0.73, which is kind of random and it doesn't really show anything. But the next diagram is showing also indirect similarity, which means this is a fuzzy AI, and this number is similarity when fuzzy AI play with real AI, and we compare those data each other, and it shows more than 0.91, and which means a high similarity. And this is more complicated one. This shows the direct, indirect similarity for human player Kaori equal Riku, and also fuzzy AI normal. And the second line, third line is the opponent we play with. This means the player Kaori out of match of Kaori and normal. And the blue line is match opponent, direct similarity. It again doesn't really tell anything, but the orange is same characters. And it shows high similarity, always more than 0.70. And also interesting thing is similarity between the same character, the different character. Like for example, Kaori versus Ippo, there is 1, 2, 3, 4, 5, 6, 7 lines for it. And the lowest point is 0.57, and the highest point is 0.68. And it means the difference is only 0.11, and it indicates that the behavior with even with another player, it's also still maintain similar behavior. This is my conclusion. Firstly, a typical rule-based AI system preserves its play style regardless of its difficulty level. Secondly, people mostly keep their play style even when playing against different opponents. And people are diverse, they are different or similar to other people and or AI systems. And there is no easy way to tell whether the given player is human or not. And finally, it is possible to compare play style of the player A and B indirectly by comparing the recording of matches of A and B against other players. And this is future work. So from our research, I couldn't show the difference between AI and the human player. So we will do research about further with Turing test to see if human can identify from their behavior. And if they can do that, we will see what is the difference and if we can make it for a program. And of course, our focus is creating human-like AI. Thank you for listening. Sorry about the trouble.
Thank you very much. Very interesting presentation.
Thank
Dr.
you.
Petrosyan, do you have any questions?
Yes, hello. Thank you for asking. So about the rule-based approach, actually, it's very interesting. At the previous presentation, I asked about this. Can you hear me? Hello?
Yes. Hello.
Yes.
So I ask about this because, well, that's faster and simpler alternative to reinforcement learning. So that's why I'm very interested. Can you say about the rule-based approach? How to construct the rules automatically? So do you know any, it's my personal interest, do you know any approaches about constructing rules automatically? Because in this type of the model, maybe you don't have the data set, you only have the environment where you can train the agent, right? So can you, using this environment, try to construct rules automatically without defining the rules by yourself? Well, this is, I'm just interested whether it's possible or not. It's my personal interest, personal research interest.
We are focused on for that as well for next research, and we are currently work on ACAI, which is also use Monte Carlo research like the other presenters method, and which is tend to work for fighting game, but it's still progress, and I can't say yes or no like currently, but yes, we are focused on using Monte Carlo research or also like a deep learning, like a reinforcement learning is a possible method, but yeah, we cannot say yes or no.
And for Monte Carlo research, what kind of optimization method do you use? Optimization, for rule optimization.
Sorry, I cannot answer this question. I'm sorry.
Oh, okay, no problem. Oh, okay, thank you very much. It's very interesting direction. I would be happy maybe in future to somehow join this research with my team, and we would be very, very happy. Yeah. Thank you very much. Thank you.
May I then comment on that, please? Because I'm an author of both papers, so
okay.
Yeah. Yeah, well, in general, yes, I agree. So I just wanted to add that, of course, when you talk about making rules automatically, the question is, what do you mean by rules? Because if you take, for example, the system that is built into Universal Fighting Engine, then it has rules in the format which are suitable for human creation. So they're convenient to make by hand. But that was a choice of the author, right? And if you mean that there is a certain neural network or classifier or Markov chain that or finite state machine, that's also in a way it's rules. Yes, it's just not the rules that are defined in human language. So if by rules we mean, for example, this type of finite state machine, that yes, of course, we can make these rules automatically just by analyzing the data, analyzing the game recording, extracting these rules from them. Yes, and speaking of Monte Carlo research, I think we just use some conventional methods which are described in literature, so we don't really invent anything. And the only novelty which I perceive there is that we're trying to use it to this probabilistic environment, because most research on Monte Carlo research, they are in domain like board games, where you mostly deal with deterministic games, not the games with these probabilities and actions which might end up in different results, let's say. So that's it.
Thank you very much. It's a second presentation by Game Dev. It's very interesting, I think.
Yeah, thank you very much.
Thank you. So unfortunately, Gerasimets is absent right now, and so the next presentation is study on Moir pattern phenomenon, and the presenter is Guo Zhao and Chen Yang. I can't see. Guo Zhao. or Shenyang. They are also absent, unfortunately.
Well, I have to remind that their talk is not scheduled until 12, so maybe we should just wait until 11:45 when Gerasimets or them will be here.
Oh, I just sent the message to Gerasimets. Unfortunately, she can't participate.
Okay.
And what about Kuo?
Let us pause until 12 when their talk is scheduled.
Yes, in such a case, it's probably better to shift the break rather than shifting all the presentations, because it could be that the presenters are just in time. Just as an option, probably not, but still. Shifting the break is better.
Yeah.
Yes, I agree.
So I think we have a break until 12, and if the speakers will be here, we'll start. Otherwise, we will have a prolongated break until 12:30.
Okay, so we have a break until 12, and see you at 12.
Okay, dear colleagues, the next talk will be in less than a minute, so I suggest that the speaker share his or her screen.
Okay, yes. Guo Zhao. Can you hear me?
Hello, Professor.
Oh, hello. Ah, you okay?
Hello.
Okay. Chen Yang, you are going to present. Am I right?
Oh, yes.
Okay, great. You can start, please.
Okay. Good afternoon, Professor. I'm an undergraduate student of Yan, United States. My name is Chen Yan. My thesis title is Study on Moore Pattern Phenomenon. It's completed by Guo Zhao and me together. I mainly talk about this paper from 3 parts. The part 1 is the background introduction. The part 2 is the flight Moore equation. The part 3 is the space Moore equation. There are the Moore patterns that are common in life, such as window screen, multimedia screen. Moore pattern is a phenomenon first discovered by 18th century French researcher Moore. It can appear in overlapping goals, camera equipment to capture screen, scanner to record image, and printing equipment to print image. It's of great practical significance to study the mechanism of Moore lens. The principle can be applied to measure the diameter and spacing of fine lines, avoid Moore pattern in image photo, and obtain pale and true image date. In this paper, the Moore pattern functional equation under difficult conditions is obtained by calculating the length of grid intersections. The series is simple, and the results are in good agreement with the actual Moore pattern. Chapter 2. Suppose there is a straight line in the plane, and the equation satisfied by the straight line is this. We clone it, and the intercept of the clone is di. Multiple clone to fill the own plane. The grid equation composed of straight is this. I lines represents the I line. BI represents the overall translation. By the same token, we construct a J grid. When the I and J satisfied the following relationship, 2 kinds of Moore patterns will be formed, namely N-type and M-type Moore pattern. I line and G line meet. I minus G is N, and a series of intersection ports will form N Moore pattern. The I line and G line meet. I at G is M, and a series of intersection ports form M Moore pattern. We know the scope of any 2 ports on straight line is the same. So we prove that the N and M Moore patterns are linear, and the equation is this. The grid spacing is constant in practice, not to intercept when we establish the grid equation dg. As shown in the figure, The relationship is dj calculate dj equal to dj times cosine theta. In order to simple the calculation, we set up axis with one of the grid lines, and the upper part is the integer. The Moore equation can be reduced to this. It can be seen that n-type or m-type lines are composed of a series equidistant Moore line, and the space is dn dm. We join the two formulas into image. The transfer coordinate is the angle between the two grid lines, and the ordinate is Moore spacing. The dn is n Moore line spacing, and the dm is m Moore line spacing. With this animation, it can be seen that the increase of rotation angle theta, the angle of grid line, is satisfied 0 less than theta less than a half of pi. The distance between n Moore lines is larger, and the angle between grid lines is satisfied a half of pi less than theta less than pi, and distance between m Moore lines is larger. Chapter 3. Just now, we are talking about the case of the two grids in the same plane. When they are in difficult planes, we project them on a particular plane by co-projection, as shown in the figure. Here are two grid equations. Next, we construct a plane of observation port grid line and find the intersection line between the plane and the projection plane. This is the intersection line equation. At that port, the method of finding the plane Moore pattern is used. We only need to bring in the I and J that meets the specific conditions to obtain the spatial Moore equation. When the Moore pattern is I minus G is T and I minus G is minus T, we can obtain the equation satisfied by eliminated the parameter I and G. For vary the hotness of the Moore equation, we use the jailbreak drawing software and drawing the graph of the equation. So, showing the figure, we can see that the image is constant with the simulated image in Cinema 4D. This is the end of my report. Thank you.
Thank you very much. It's very interesting. I think it's valuable for clothing industry. And I have one little question. Do you have any contacts with clothing industry, and maybe you show these results to them?
Okay. My synthesis can be applied to measure the diameter and spacing of fine lines, avoid Moore pattern in image photo, and obtain pure and true image data.
Okay. So you can apply these methods not only to clothing industry, but also to some image functions. Image. Am I right, or it is not correct?
Sorry, I don't understand.
Okay. As far as I understood, these results can be applied to clothing industry when people create T-shirts or something like this, and they want to make these T-shirts. Okay, I see you can't understand.
Okay.
Anyway, it was quite interesting for me. Colleagues, do you have any questions? Maybe Dr. Petrosyan or Dr. Blikanov?
Sorry, can you tell me, please, what kind of instrument did you use for modeling and testing? How did you verify your result? What is program language did you use? How did you test? Test.
Yes.
How did you verify your result? Maybe what is framework did you use? Framework. You use Python. Maybe did you use Python or MATLAB or C++? You show picture. You show picture. How
okay.
did you get it? Yes, this previous slide. Okay. Next slide. Next. For example, yes. How did you get this picture, this image?
This image. We used simulator image in Cinema 4D.
Okay. Okay, thank you. It was an interesting presentation. We have break right now until 12:30. Am I right, Dr. Yeromin?
Right. We have the schedule at 12:30. We will start the second long part of our today's session.
Okay, great.
Okay, so, thank you.
See you in 15 minutes.
Thank you.
Okay, colleagues, we can continue. It is 12:30. So the next presentation is from Karlsruhe Institute of Technology. Okay, Adam Kastner, you are welcome. You can start.
Hello, my name is Adam Kastner, and today I am going to present some of our work on abstractions in the modeling of DC-AC power converters. Such converters are becoming more and more widely used due to the introduction of new technologies such as renewable energy sources, battery storage, and HVDC transmission. But they also pose new challenges such as stability issues that arise due to their dynamic behavior and losses created by the harmonics arising from the high frequency switching. In our work, we have considered a specific type of power converter, which is a three-phase, three-wire, two-level voltage source converter. The electrical diagram is shown on this slide. And we make the assumptions that all components are linear and time invariant, and that we know their parameters exactly. We also assume that the switching elements are ideal, and we do not impose any limits on the currents. We do, however, impose limits on the voltages to ensure that the converter operates in force commutated mode. And to model the three-phase AC side, we will use only two coordinates using the method of the Clark transformation, which I will now briefly explain. If we were to model the AC side using three variables for the three phases, we would obtain a differential algebraic equation. With this algebraic equation restricting the state space. To avoid this, we will use the Clark transformation, and in any three-wire system, the sum of the currents is restricted to be 0. Therefore, the phase currents must lie in the null space of this matrix G, and this can be represented as a linear combination of these two vectors here. And we can obtain the variables I alpha and I beta using the Clark transformation. A similar transformation is also applied to the voltages, and by this method we obtain a ODE system in only two coordinates. I will now present various mathematical models for these converters, two kinds of switching models, two kinds of averaged models, a linearized version of the averaged model, and also a nonlinear model in discrete time. The first model is obtained by using the physical principles, the Kirchhoff's laws, to obtain equations for the system, and we represent the voltages and currents at the switching elements depending on the switching signals. From this, we obtain a state space system where the state represents the voltages and currents of the storage elements. The control input represents the switching vector, and external voltages and currents applied to the system are represented by an additional uncontrolled input. The model structure is bilinear in the state and control input U, and linear otherwise. An alternative but equivalent way of modeling the system, including the switching behavior, is done by modeling each switch configuration of the system separately. When doing this, we obtain a linear model with a time-varying system matrix A. This can either be obtained directly using the physical principle of Kirchhoff's laws, or from the bilinear system if this was previously modeled. We present two possible ways of representing the input. Firstly, we can directly represent the time varying system, the mode selection function, which defines the time varying system matrix, or indirectly using a static but time varying system which represents the pulse width modulation actuator. In many cases, this time varying behavior is not desired for system analysis, and we obtain a time invariant model by averaging, which is done over a short period TS. This is typically the period of the PWM actuator. The states and inputs of this new model are now the averaged versions of those of the bilinear model with discrete inputs. And when we assume that the ripple of states, the ripple in the states is small, we can replace the average of the product of state and input with the product of their respective averages. And we then obtain a model that has the same bilinear structure and also the same parameters as the model for bilinear, as the model for the discrete inputs. However, the states and inputs now represent different quantities. In a balanced operation, the voltages and currents on the AC side are sinusoidal quantities, and those can be transformed into stationary quantities using a time-varying rotational transform. And when we apply this to all AC states and inputs, we again obtain a bilinear model. However, now in the stationary coordinates D and Q instead of the rotating coordinates alpha and the rotating coordinates D and Q instead of the stationary coordinates alpha and beta. The structure is the same. However, the matrix A0 now includes additional cross-coupling terms. And this is equivalent to the average model in stationary coordinates via the reverse transformation. From the stationary equilibrium of this model, we can perform a Taylor linearization to obtain a linear model, which is used for small signal analysis. States and inputs now represent the deviations in the rotating coordinate frame from the equilibrium or operating point. And we obtain the system matrices directly from the matrices of the previous bilinear system. Linear models are quite popular in the analysis of these systems, and there are also other methods of obtaining them, such as an assumption of a constant DC voltage. This leads to a different linear model, which is also often used. When we now return to a lower level of abstraction to the switched linear model, we can also obtain a discrete time model by solving the ODE system exactly. For this, we assume that the uncontrolled input follows some linear dynamics, and we obtain an extended version of the switched linear system where the state now also includes the uncontrolled input. We can obtain the evolution of this state for a specific sequence of modes with their respective durations. And this system is nonlinear in its nature due to the sequence of matrix exponentials in the system equation. We have simulated all these models to demonstrate the differences in their trajectories. And for this purpose, we have designed a feed-forward control signal based on the approach of differential flatness for the averaged system in rotating coordinates. A flat output is a fictitious quantity, which is not necessarily corresponding to any real output, with the important properties that its components are differentially independent and that we can obtain the states and the inputs directly from Z and its derivatives. For our system, an appropriate choice of the flat output is the total energy stored in the system and the reactive current. When we simulate our systems, we obtain these state trajectories. We can clearly see the high frequency ripple in the switched model. In this case, the bilinear model with discrete input was simulated. However, the switched linear model is equivalent and obtains the same trajectories. We also simulated the average models, which are very close to the average of the switched model. This is not exact because of our small ripple assumption, which causes a small deviation. For the linearized model, we can see that this matches very closely in the beginning. However, there is some deviation later on when we move further away from the operating point about which the Taylor linearization was performed. If we now consider also the discrete time model, we can see that it matches the switching model exactly in the sampling instance. It is, however, does however not match exactly the averaged model. Again, this is because this is a different kind of simplification of the system. The bilinear, the averaged model includes a small ripple assumption, which the time discretization does not. The input signals for the various system types are also quite different. We have continuous valued input signals for the averaged models. We have discrete vector signals for the switching bilinear model. And for the switched linear system, we have we have the mode selection function with its 8 discrete values. These are not trajectories, these are these input signals for a small amount of time. In conclusion, we have shown that various degrees of abstraction are possible in the modeling of power converters, and these different models can then be used to apply different methods. For example, we can perform high fidelity simulation using the switching model. We have simplified analysis with time invariant averaged models, and we can use the linearized models to perform frequency domain control design, which is a very common application of those models. In the future, we hope to analyze the stability implications that exist between those models, because the engineering literature is quite sparse on the stability properties of switching systems. However, there is already mathematical groundwork in this area, for example, from Mr. Gallick at the St. Petersburg State University, but also from others. And we hope to verify the obtained results using experiments at the Karlsruhe Institutes of Technology Energy Lab 2.0. These are the references we used in our paper and for this presentation. And I now thank you for your attention, and you can ask any questions if there are any.
Thank you very much. It was very interesting. Dear colleagues, do you have any questions? Maybe Dr. Peterson?
Dr. Peterson is not here right now.
Yes.
So I have a question to
Great.
When you obtain a system of differential algebraic equations, what solvers are you using to obtain the simulation results?
We do not use the we do not perform any simulations for the differential algebraic equations, because we can apply the Clark transformation to obtain ordinary differential equations, and we only simulate ordinary differential equations.
Right, but later you have a system with X and W. Can you turn some slides back?
Yes, which slide is it?
The one where you get a system with X and W in the same vector.
Yes. So for this system.
Right. Here, as I see the matrix, a wave is due to omega capital. And,
yes.
It's singular, isn't it? The matrix is degenerate, so this means that the system is a system of differential algebraic equations.
No, this is still a system of ordinary differential equations. We only have a starting condition on W, but we do not have any algebraic restriction.
Okay, maybe. All right, it's just a 0 row. Okay. So you just reduce the size. All right.
Okay. Thank you very much. It's time for the next presentation.
All right.
The next presentation is real-time test bench for inverse sliding mode control experiment.
All right,
Yes.
welcome everyone. I hope you can hear me all right.
Yes, we can hear you. Thank you. You're welcome.
All right, perfect. My name is Jan Wachter, and today we'll present you our paper with the title Real-Time Test Bench for Inverters, a Sliding Mode Control Experiment. My colleague, Mr. Kastner, already introduced some of the challenges arising from inverter interfaced systems for the integration of renewable energy resources in the existing electric grid. I want to show a little bit about the generic setup of such systems for small motivation. You have always some sort of DC source that could be a PV field or like a wind turbine system providing the energy. Then you have some sort of inverter system, which is giving you the three-phase reference or the three-phase voltage common for the utility grid. This is connected via a grid filter to remove higher harmonics and show a better compliance behavior with the grid code to which the system is connected. PCC is short for the common for the point of common coupling, which denotes the connection to the overlaying grid. In our case, this will be our real-time test bench, giving us some sort of grid emulation. We are using for our experiments for the DC source, we'll use a high bandwidth voltage source to give us the necessary DC voltage. For the inverter system, we're using a neutral point clamp topology. What that means, I will tell you in a second. The grid filter, in our case, is a simple LC filter. And as I mentioned, the point of common coupling is the connection to our experimental setup. In this picture here, you can see the prototyping voltage source inverter. So we have some sort of controller that we can program. The sliding mode controller I will introduce later. Here you can see the inverter system, and down here the grid filter, just to give you some pointers on how the system looks like. Next, I want to introduce the neutral point clamped inverter topology. In contrast to the system Mr. Kastner showed before, this is a three-level inverter, meaning that at the output of the inverter, you can have three voltage levels. That would be either ground, VDC plus, or VDC minus. If you use Kirchhoff's laws again, you can obtain the following equation for each of the three phases. Then we are applying an averaging approach, as Mr. Kastner explained in the talk before. And we use the following mapping to control notation, as you can see in the table, and we obtain a linear system. The main assumption we made here is, for one thing, that the DC side dynamics are neglected. So we have constant DC voltage. And of course, the averaging of the physical signals over one period of the PWM generator. Using this system, I now want to show you the design of a sliding mode controller, which we'll use to get a sinusoidal reference voltage at the connection to the grid, and so provide the known three-phase grid voltage. And I want to start with some small basics about sliding mode control. It's a concept for variable structure control, which has certain properties for the trajectories. It's split in two parts. One is the reaching mode. It's better seen in the picture. So the trajectory is reaching the so-called sliding mode, which is denoted here by this line. So first the trajectory reaches the sliding mode and then is sliding on the sliding modes towards the equilibrium. In the following, the sliding mode is known as S with the condition sigma. And of course, to drive the trajectory to the sliding mode, we need some sort of controller, the sliding mode controller here in a general form that has the properties that it has a discontinuity on the sliding surface. Why are you using this approach? It has some advantages with respect to that it's quite robust to parametric uncertainties as well as to disturbances. Also, it is well suited for variable structure systems. And you think about the power electronic device, the inverter. It has switches inside, so it has a variable structure. What is making us use this sort of approach? And of course, the implementation always comes with some challenges, some problems. One phenomenon that is often arising is so-called chattering. In that case, you're not ideally sliding anymore, or you're losing the ideal sliding property on the sliding mode, but instead you're jumping up and down, above and below the sliding surface. This stems from the fact that in theory, the control would switch infinitely fast between the two continuous control laws. But of course, in real implementation, infinite fast switching is not possible. Next, I want to demonstrate how to design such a sliding mode control with the example given for our three-phase inverter system. The design process has two basic steps. The first step is to find a suitable sliding surface. In our case, we want to follow the reference signal, like a symmetrical three-phase signal. So we're defining the sliding surface using the tracking error and its derivative. Because it must be of degree 1, with respect to the control input, we need the derivative of the tracking error here. Using the state space equations from the slide before, we get the following expression for sigma. The second step, of course, is to find a control law that is ensuring finite time convergence to the sliding surface. The condition is given here for sigma and its derivative. And if you look in literature, you can find several sliding mode controllers that are sufficient, satisfies this condition. In our case, we have used the super twisting sliding mode controller, which has several advantages for our application. Since it's reducing by design the chattering effect, chattering phenomenon, and with the switch case for the helping variable omega, W, I mean, sorry, you can limit the control output to Umax, or the absolute value of the control output to Umax, what is quite interesting for us since the duty cycle has inherent limits. So this is favors for our approach. When you talk about restrictions on the control, or for which conditions the sliding mode exists, you can use the so-called equivalent control approach. The basic idea is to find the necessary control signal to stay on the sliding mode once you're on it. So in the sliding mode, sigma is 0, so by extension, the derivative is also 0. If you look at the derivative of sigma and you insert U equivalent, you can get the following expression. And now you can see that if you can make your control arbitrarily large, and assuming that your phi here has some upper bound, you can always stay in the sliding mode. But of course, in practice, you cannot be as large as you want it to be, but it's limited by Umax. So you have some limits on the existence domain of the sliding mode. If you look at the equation above, you can see that the disturbances, which in our case we consider the grid currents or the load current of the inverter, contribute to phi. You can see that large derivatives or large load currents are critical for the for the control system at hand. So that is something we should, I will show you later in the experiment, we tried to find. Another interesting application of sliding mode theory is the design of differentiator systems. The control approach we showed uses the derivative of the phase voltage and the phase voltage, of course. The phase voltage can be directly measured, but the derivative cannot. We're using a so-called Levant differentiator, which can be derived in a similar fashion or almost analogously to the shown super twisting sliding mode controller to obtain the derivative of the voltage signal. It has some quite interesting properties. So, for example, small sampling times are uncritical for the Levant differentiator, and also the maximum error of the differentiator depends on the magnitude of the noise, and we do not need to make any assumptions about the frequency band as for normal linear differentiators. The differentiator system is shown here. Some small hints on the design of the parameters lambda 1 and lambda 2. If you know the upper bound of the second derivative of the signal that you want to obtain the derivative of, you can use that information and design your parameters accordingly. If you look at the references in the full paper or at the original paper by Levant, you will find also alternative ways to determine those parameters. We implemented the super twisting sliding mode controller as well as the Levant differentiator for our real-time inverter test bench, as the basic setup is shown here. So we have the DC source with the high bandwidth voltage source, the inverter with the programmable controller that is generating the gate pulses and is directly controlling the switches of the three-phase inverter. It's connected with the grid filter to the other part of the experimental setup, which in this case was denoted for a passive load, so some light bulbs, some normal resistors in the system, and an active load. We've chosen the active load to introduce some fast load changes and large load derivatives. As mentioned before, those are considered critical for the sliding mode. Now I want to show you some quick results from the measurement campaign we conducted. The first goal was, as mentioned, the tracking of the reference voltage, so to provide a sinusoidal reference voltage. I'm just showing the measurement for one phase, but the control is the same for every phase, so it will just overload this plot. You can see in black the reference voltage and in red the measurement, and you can see that the measurement is following the reference trajectory quite well. And in the lower plot, you see the performance of the Levant differentiating system. The reference for the derivative is given by or is directly taken from the reference for the voltage. You can see that the expected phase lag that is inherent to every differentiating system that is implemented in real time. You can see here there's always a trade-off between noise amplification and phase lag. If you wonder about the ripples that are quite visible here, if you zoom in, you can see that the same ripples occur in the voltage measurement, but due to the scaling of the first plot, you could not see them clearly. And now the fast change of the load current I talked about. Here you can see a zoom plot of the load current provided by the system. It is changing quite fast, and you can see that the voltage is, of course, disturbed by that. But this disturbance is recovered quickly, and the system is behaving as nominal again. Most of the time, I will make this short. We can see that the real-time test bench was able to, or we were able to implement the advanced control methods we wanted to, and that the sliding mode controller is showing the expected behavior, especially with robustness towards the large load currents we saw. And further studies will include the extension of our test bench, of course, to study the interaction between different inverters. So if you connect multiple ones at the point of common coupling. And the next one would be to study different control modes. So not voltage controlled, but for example, current controlled, or inject P and Q, so active and reactive power into the grid. Thank you very much for your attention. That was everything from my side. And if you have questions, now would be a good time.
Okay, thank you very much. It was very interesting. Dr. Yeromin, do you have questions?
Unfortunately, we don't have any time for questions
Yes,
left.
yes. Unfortunately. Okay, thank you very much once again. Actually, unfortunately, I can't see the next presenter.
He's here. Li Jupin is here.
Yes,
okay,
Professor.
She.
Hello, Professor. Can you see my screen?
Just a moment. Yes, I can see. Great.
Okay. Hello, everyone. My name is Li Jiping. Our group report is a report single angel reinforcement learning, review of deep learning approach. And there are three parts in my report. First one is an overview of deep learning. Second is algorithm. And the last one is application of reinforcement learning. First, let's see what is deep learning. The concept of deep learning originates from the research of artificial neural networks and the multi-layer person portrait MLP with multiple handle levels is a kind of deep learning structure. Deep learning forms a more abstract high-level representation by combining novel features to discover distribute feature representations of data. This is the algorithm field chapter of reinforcement learning. DDQN. The DQN cannot resolve the inherent shortcoming of Q-learning over estimation. Overestimation means that the estimate value function is larger than the real function. If the overestimate is uniform in all states, then according to the graded stages, the action with the largest value function can still be found, but often the overestimate is not uniform in each state. Therefore, overestimate will affect the strategy decision. Result is non-optimal stage. And result, this is their function. And this is the action reaction. The action reaction of the TD tag in Q-learning is in the next state, ST+1. Select the action max that maximizes the state action will function. Max A QST+1 A certainty. Action settlement. Action elements refers to the optimal action AT+1 star in the next state. To construct the goal call ST+1 AT+1 star theta t. And this is the DDQN with prioritization. Okay, let us say the actor security. With which common being plus gradient actor and function approach makes critical. Actor gives an action critical elements the cue of the action given by the actor. The generates a team differently single to get the update of theoretical and actor. The object function of actor theoretical is this. And the logical pi theta st is this actor, and co-pi s a minus v pi s is this theoretical. Algorithm actor critical. How good are the action we take from critical state? Co-pi SA is this. The average return when other agent face the state. Advantage function, which refers how good action we have taken compared to other candidates. A pi SA equal co-pi SA minus v pi. Okay, and then we talk about the last algorithm, deep deterministic probability gradient, DDPG. DDPG is labeled the DQN algorithm in continuous action space, many of which can be found in DQN algorithm, and its various variants. At the same time, DDPG is different from the above method various algorithm. It's an often placed algorithm, so it requires experience payback and aiding diagnosis. Since the real function of DDPG estimates that the natural network estimates the action state value value. It needs to take the state and action as input to output Q value. At the same time, it draw on the reply buffer and the target network in DQN and the software update method for target network. There are 4 natural networks in this algorithm. Namely plus network, value network, tagger plus network, and tagger value network. But deterministic probability gradient might not explore the 4 states and the action space. To overcome this, we introduce a lossy process and recall that we use epsilon gradient approach in DQN to ensure exploration. We want to maximize the word Q values revealed over the same per minute batch. The gradient is given as this. We can say if the DDPG agrees optimal person for the class inverted field test. The blue line is the return, and the orange line is our age return. Last, we talk about the application of reinforcement learning. This is 5 application in automatons, witches, robots, and industry automation, application in trade and finance, application in health care, reinforcement learning in games, application in autonomous vehicles. Reinforcement learning can be applied in autonomous driving tasks such as trajectory optimization, multiply dominance, control optimization, and serial-based heavy learning schedules. This is robots and industry automation. We also application in trade and finance. Real-time service models can be used to produce future service and predict stock price. Inter-reinforcement learning. The reinforcement learning agent can decide to perform this test whether to hold buy or sell. Application in healthcare. Reinforcement learning in games. Through reinforcement learning, AlphaGo Zero decides how to go according to create a chess game. It relies on the symmetry search of a single natural network to evaluate the positive movement and movement. And that's what. Thank you.
Okay, thank you very much.
Thank you, Professor.
Colleagues, do you have any questions? May I ask one question? You gave some applications?
Yes, sir.
Oh, Dr. Peterson is coming. Okay. Now, you showed some applications, and I didn't understand clearly if it's if it's a list of applications that you can do, or you made this application already.
I just learn about it, but no, I don't realize it, and I know in the future we also can do it.
Okay, so right now you have so-called theoretical bases for make these applications in future.
Yes, sir.
Okay.
Maybe I can ask a question. Maybe I didn't hear it, but you talked about different approaches for reinforcement learning. Have you chosen one approach to implement which is better than the other?
Can you say again?
You have talked about different approaches to reinforcement learning.
Yes.
Do you have one best approach, or they all are competitive?
No, I don't have.
So there, one is better for one situation and another for the other.
Sorry, maybe I can help out.
Yeah, great.
Overview presentation that the students have prepared. Also, there will be another two presentations. They are on the stage of research and learning, and this is the result of their research and learning. Of course, they have research direction. They have specific tasks, but now at the stage of they are at the stage of learning. As any good research, you should first understand what you are doing and then apply it. So that's why it's an review. That's why it's a review presentation.
Okay, thank you.
Thank you, Professor.
The next one, it is Lee Ik from Yan'an University. Is design and implementation of online education system based on B2C mode. Yes. Or reported by Fanfan. Okay, okay. Fanfan, you are welcome. You can start.
We can't hear you.
Yeah, sorry, Fanfan, we can't hear you.
No sound, sorry.
Maybe you have some problems with your device.
Okay, maybe co-author would.
Maybe your co-author, Lee Ike.
Can you hear me now?
Yeah, we can hear you.
I'm so sorry about wasting your time.
No problem.
I will begin right now.
Yeah, you're welcome.
Good afternoon, professors. My name is Fan Fan. I will complete the defense with my partner, Li Yike. The title of our paper is Design and Implementation of Online Education System based on B2C mode. Next, I will introduce our system from these 6 aspects. Number 1, introduction. Number 2, present situation. Number 3, B2C mode. Number 4, functional design. Number 5, database design. Number 6, system implementation. The first is introduction of this article. Our education is network-mediated teaching method. Through the internet, students and teachers can carry out teaching activities, even if they are separated by thousands of miles. Especially under the influence of COVID-19, online education has become an indispensable educational method for enterprises, schools, and other places. This paper designs and implements an online education system with strong accessibility and beautiful interface. Next, please take a look at this picture. The bar chart of the database released by GSV. We can clearly see that global online education market has grown steadily from 2015 to 2019. And according to the GSV Global Education Industry Report, the CAGR of global online education remained at 23% in 2017. In the next few years, with the upgrading of online education technologies, or the combination of big data, artificial intelligence, and other mainstream technologies, it will be further promote the substantial growth of online education market size. It is clear from the data that online education industry is growth rapid. So a good online education system is easy to accept for people nowadays. Now, let me introduce the business mode that we use. B2C mode actually is to produce a large number of self-owned copyrighted videos and put them on their own platforms, allow users to pay monthly and annual fees. This model is simple and fast and can be developed quickly as long as one focuses on it. On recording a large number of videos, it was made popular by the sky-high financing of Linder. In the middle of function, the representative online education system are shown in the right. One is Linker in the United States, and the other is IMOC in China. Now, next comes to the system design. Figure 2 shows the overall architecture of the system. The application layer of this platform is a mobile phone or web browser. NGX is embedded to facilitate the package and release of subsequent service. The data line uses Redis cache technology, and the database uses MySQL 5.7 version for data storage and management. And the next, in the middle of this business layer, which includes functional modules such as course preview. Next, let's look at the pictures 3. Picture 3 shows the overall functional modules of this system. The system is mainly divided into 7 modules. For example, the login registration module, lecturer management module, and course management module, and the 4 other modules. We will explain it later. Now, these 3 pictures show the specific functions of the 3 modules: the management module, course management module, lecturer management module, and the personal center module. Taking figure 5 as an example, the course management module is divided into 3 intermediate modules, includes lists, details, and learning. The list also contains searching and sorting functions these 2 courses. Other parts are also divided like this. Only when the system is divided into the detail and clearly modules, it could be easy and convenient for people to use. Let's look at the database design. After functional design is the system database design. Figure 7 shows the ER chart of system meaning between entities. The attributes of each entity can be clearly seen. One of the course can be bought by more than 1 student, and one class can be purchased by multiple learning courses. So it is a many-to-many relationship between the curriculum and the users. With detailed and correct ER diagrams, we can design a reasonable database. Table 1, 2, 3 shows a database table of teachers, courses, and comments, respectively. After functional design and database design, we can look at the implementation of the system. Now, we can separate front end from the back end of the system. Front end technology includes Vue and Node.js. Back end technologies include Spring Boot, Spring Cloud, MyBase Plots, Redis, and Easy Excel. Third-party technologies includes Aliyun OSS, Radio on Demand, and the database use MySQL version. We can all look at this vision on this paper here. Now, I will explain the demonstration of the main functions of the system. The last part is demonstration. Because this system uses Spring Boot microservice architecture, there are so many small services in it, and it takes a lot of time to set up. So we take the function of uploading video as an example to explain to the professors. As shown in the figure 8, it is a front page display of the system. Figure 11 shows the back-end interface of the system. When the user logs into the back-end of the system, the video and user's personas can be edited. As shown in figure 9, it is a video editing interface of the system. After the uploading information of video classification, cover, and price, etc., we can see the video lessons and introductions we uploaded on the front end, as shown in the figure 10. This is a simple video editing process. Students and teachers' information modification is the same process. Thank you. That's all our report. Thank you for listening. Now it's my.
Okay, thank you. Thank you very much. I guess you have some problems with connection. Do anybody have some questions? Can you hear me?
I can hear you.
Okay. So you implement your system to real process, or it's just some test process or artificial process?
In fact, some parts of our country, they has actually used some of the system, but this system, I believe, implements some new system like Node.js and MySQL and etc. And it can lead users to upload and conserve their videos for studying more clearly.
Okay. Thank you very much for your presentation.
Thank you very much.
Thank you. So we have 3 minutes until next presentation, already 2 minutes. Okay, the next presentation is explainable artificial intelligence, review of local explanation methods. You can, Liu Xiu, you can share your screen and start at 30:30.
Hello, Professor. Remy and I will talk about XAI, but we have to talk about the global method first. So can we let Remy go first?
I think we have to follow our timetable, so let's begin at 13:30 with review of local explanation methods.
Yes.
Александр, тут 2 доклада, один про локальный, другой
You
про
can share
глобальный.
your presentation.
Okay, Professor.
Александр, меня слышно?
Да, вот слышу.
Вот у нас 2 докладчика, у них сначала про глобальные они хотят рассказать, а потом про локальные. Мы поменяем местами вот этот и в 14 часов, чтобы они могли в порядке, в каком им нужно представить.
Can you hit?
14 часов. Окей, я понял.
Okay, I will start. Hello everyone, I'm Ma Ruimi, a graduate student of School of Applied Mathematics and Control of St. Petersburg State University. And the topic I'm showing today is explainable artificial intelligence, a review of global explanation methods. The one who completed the work with me was Dr. Zhang Yuyi, and I would like to thank my mentor, Alvanas Petros, for his guidance on our work. And I will introduce from the following three aspects. In the first part, I will briefly introduce the background of explainable artificial intelligence. Artificial intelligence system has been widely used in transportation, security, medical, medicine, finance, law, military, and for example, the following figure shows such a deep learning model F, which accept input X and generate an output prediction Y. Machine learning model are often obscure and non-intuitive. It's difficult for people to understand why such predictions are produced. At that same time, users have many questions such as when can I trust the predictions produced by the machine? Why doesn't the machine do something else? When will it succeed? When will it fail? But why is there such a prediction and why should we believe it? Let's take a look at specific project in 2017. The machine learning system judged that the creature in the picture is a cat, and it didn't give a detailed explanation. But XAI explanation, the creature in the picture has 4 whiskers and clothes, beard and clothes, as well as the following characteristic of cat ears. So prediction result is 1 cat. And now people understand why AI made this decision. So we come to conclusion that explainable AI is an intelligent system whose actions or predictions can be understood by humans. And with the use of AI algorithm in healthcare, credit scoring, law acceptance, and more, the need to explain a machine learning model result is important for ethical, judicial, as well as safety reasons. Even though there are different factors to why XAI is important. Our study suggests that the most important concerns are threefold. Transparency, traceability, and bias and fairness of AI algorithm. Current business models include interpretation as a step before serving the machine learning models on production systems. However, are often limited to small tree-based models with use of highly nonlinear deep learning algorithm with millions of parameters in machine learning pipelines. XAI techniques must improve all three concerns mentioned above. And in the second part, I will briefly introduce the structure of XAI research. In this picture, we can see that the 3 major structures of XAI research. The scope of interpretation can be local and be local or global. Some methods can be extended to both. The local method focuses on the overall planning of individual data instance. generate and explain a map. The global approach attempts to understand the model as a whole. Usually, a set of data instance is used to generate one or more explanatory diagrams. The core algorithm concepts behind interpretable models can usually be categorized according to implementation methods. Generally speaking, both locally and globally interpretable algorithms can be divided into back propagation-based method or perturbation-based method. The core algorithm logic of back probe method relies on the gradient propagation backward from the output prediction layer to the input layer. The core algorithm logic of the perturbation method depends on the randomness or carefully selected changes of the features in the input data instance. Also, a well-developed interpretable method with a specific scope and method can be embedded in the neural network model itself, or can be used as an external interpretation algorithm. Intrinsic means that interpretability is embedded in the neural network architectures itself and usually cannot be transferred to other architectures. Post hoc means that the XAI algorithm doesn't depend on the model architecture and can be applied to already trained neural networks. Then we summarized the pioneering work schedule of interpretable AI from 2010 to 2020. It can be clearly seen that in 2010 there was already a potential backprobe-based post hoc interpretation method. Activation maximization. And it was not until the existence of a local interpretation method based on the overall situation in the past 3 years that there was rapid development. And in recent years, we have begun to study methods that can be based on both local and global interpretations, and then continue to improve. In the last part, I will introduce a global interpretable artificial intelligence algorithm. Testing with concept activation vectors. It uses directional gaps to quantify the sensitivity of model predictions to advanced concepts of CAV learning. The concept of CAV is a vector pointing in the direction of concept value. For example, in the figure below, if a machine learning system is trained to recognize zebras in an image, then a person can use it can use testing with concept activation vector system to determine the TCAV score and get the weight of the concept of straps in the machine learning system when the machine learning system making decisions. Testing with concept activation vectors was originally tested on machine learning models trained to recognize images, but it's also applicable to machine learning models trained with text and certain data visualization. Our work on TCAV was pursued with the following goals. The first is accessibility. Requires little to no machine learning expertise of user, and the second is customization. It adapts to any concept, maybe for example gender, and it's not limited to concepts considered during training. And the third plug-in readiness works without any retraining or modification of machine learning model. The fourth is global quantification. A single quantitative metric can be used to explain the entire category or set of examples, not just a single data input. The algorithm process is as follows. In the first step, we identify the concept of interest. For example, we use straps, and the user defines a random picture that contains straps, and another doesn't contain straps. Then we give a class being started is marked as a training data example. Here we use the zebras. And give a well-trained network as shown in picture C. X is the input of dataset being started. FL is the activation of L layer, which means that the activation function that maps the pairs of the original image to the class score. And HLK is the linear classifier of the case class in the L layer. The second step is to generate a TCAV score. To quantify the sensitivity of a particular concept to the prediction result. TCAV achieves this by using the directional derivation, which can measure the sensitivity of machine learning prediction relative to the change of the concept input direction in the neural activation layer. The conceptual sensitivity of class K to concept C can be composed as the directional derivative defined as follows. If concept sensitive is positive, it means the impact on the prediction result is positive, and vice versa is negative. Here we can see the VCL is the concept activation vector. It's a vector orthogonal to the classification boundary, and it's represented by a red arrow in the figure D. The line is the linear classifier. It divided the picture. It divided the user picture to two classes. The first class contains the straps, and another doesn't contain straps. We define the TCAV score as follows. That is the proportion of the concept X sensitivity to the positive impact of the category in the entire category. The last step is to assess the overall relevance of the learned concept activation vectors and avoid.
Sorry, Ma, you're out of time. Please
okay.
finish your talk.
Okay, thank you very much for this review. The next presentation is implementation of facial mask detection in Tensor based on improved SSD algorithm. Liu Yuxing or Chan Geng, who is presenter. Okay. Okay, we can hear you, so you're welcome. Please start.
My name is Liu Yixing. I am a student from Yan'an University. Our project is implementation of facial marks detection in TensorFlow based on improved SSD algorithm. What we make is improve SSD model. In order to introduce the improved SSD model, I will develop this article into 5 parts. First of all, let me give a brief into introduction to the background. In 2019, with the outbreak of COVID-19, white mask have become most of traveling. This will produce the problem. The traditional face recognition system cannot normally complete the recognition work. In order to save this problem, we produced a new training model to improve the accuracy for face whitening mask. This models introduced the attention mechanism into the traditional SSD algorithm model and improve the recognition able by stronger seeing the feature of recognition able. Then I introduced the traditional SSD algorithm model. 然后这 SSD algorithm is the most commonly used training in image recognition. It is mean improve on basis of VLG16 model. The training model convolution layer 5 and 5 to 11 is used to extract the image factor of each layer. Many predictor feature legs can be obtained. There are many difficulties in feature information obtained from difficult layer. Then feature recognition is carried out in detection. But when it comes to reconnaissance face with mask, the identification of detail is more demanding. So in order to improve the accuracy, we introduced tension magnetization. Attention is magnetization, so it is easy to introduce the traditional model. In traditional SSD algorithm training model, we introduced the attention mechanism to the image of space damage. This is the idea of introduced way to difficult pixels of plan image. The way of the that need to be fixed will be hard. Like this, with increase and improve recognition function factor. Our must here is to input the SSD process image into another neural network for way promotion. Dropout it's also a mechanism. It means purpose is to reduce the occurrence of our fitting. I want to make a image feature less upwards before attention processing. So dropout is introduced. Then means the means method is to ignore the role of some measures in some neural network and the output fuzzy result as a simply demonstration into the right finger, the over specific feature are blurred. This is easy to information in transform and the library function can be coded. So we in production in transform there are five products 那个 reading stacks 这个是improve image and importing libraries and next is clouding training data. When the clouding training data, we normalize the image to 300 pixels, although supplement and compression and then train it, 然后model starting training use the SSD and attention drop out. At least classifier it is function to classify the result. It classifies whether the characters in the picture well marks. We test the accuracy of the model by this model. Then this is the display of our output and that's all. Thank you, operator.
Okay, thank you very much. The next, Dr. Blekanov, you have a question?
Yes, I have a question. Can you tell me, please, why did you choose SSD algorithm? For only research, did you review state-of-art algorithm in your task? Did you understand?
Can you pardon?
Why did you choose SSD algorithm? Did you review other algorithms?
这个 SSD 那个什么叫往上，这个算法的话
，Okay, sorry, but
Okay.
we have to continue. It is 2 p.m. already. According
Thank you
to
for your
our
presentation.
timetable. Thank you. The next presentation is explainable AI, review of local methods, as far as I understood.
Right.
Okay. You are welcome. Please, you can start.
Okay. Good afternoon, everyone. My name is Liu Xiu. My research direction is implementable AI. Today, I will talk about XAI, review of logo explanation methods. I will share 3 methods: LRP, EM, and SMV. The first is LRP, layer-wise relevance propagation. Firstly, let us consider pixel-wise decomposition. A natural way of explaining a classifier decision is to decompose its output as a sum of pixel-wise score, representing the relevance of each pixel for the decision. Sigma P RP equal RF. RF is the output of the neural network. RP is the relevance of pixel P. One can directly recompute the analysis at a coarser level by aggregating relevance score according to the partition of the pixel space. RP equals sigma RP. Sigma P belong to P RP. Sigma RP equal RF. We present the layer-wise relevance propagation approach proposed for obtaining pixel-wise decomposition of the model decision. First, we input XP. In forward pass, we can get XG from sigma xi. In backward pass, we can get Ri from sigma rg. Step by step, and finally, we can get RP. LRP assumed that the decision function can be decomposed as a feed-forward graph of a narrow computation of type xg equal sigma I xi omega ig plus vg. Xi is the narrow inputs, xg is narrow activation. The progression and behavior of LRP can be characterized by looking at the single narrow. The relevance RG received by narrow G from the upper layer must be redistributed to its incoming narrow in the lower layer. For this, we produce messages R from G to I that satisfy a logo conservation property. Sigma R from G to I equal RG. The exact definition of LRP role is dependent on the narrow type and its position in the architecture. However, the message can guaranteedly be written as R from G to I equal QIG over sigma QIG. QIG multiplied by RG. QIG is a measure of contribution of narrow I to activity narrow G. The relevance score assigned to the narrow I is subsequently obtained by polling our relevance messages coming from the higher layer narrows to which narrow I contributes. So I equal sigma R from G to I. The relevance propagation procedure is iteratively applied from the type layer down to the fixer layer, at which point the procedure stops. And now we will talk about AM, activation maximization. And the start of the AM is look for the input pattern that makes the maximal activation value of a given hidden layer cell. Experiments have shown that when the pupil finds the edge of the object in front of it and the endpoint is a certain direction, a narrow cell becomes active. Simply put, the narrow extracts a feature, and if the image satisfies that feature, the output of the narrow is large. So the AM algorithms maximize the activation function of narrow by entering a form composition style image X star, whose expression can be X star equal average max ZIG theta X. Theta is the parameters of the model. Once the network training is complete, parameters theta determines the value. ZIG theta X is the activation of a particular unit I from layer G. And the algorithmic processes can be divided into 4 parts. Part 1, set up a random input image to get the activation ZIG of a specific volume G of a layer I. Part 2 is a case of fixed CNN parameters calculate the activation ZIG and the gradient with the input image, the partial derivative of ZIG with respect to X. Part 3, iterate to change the pixels of the input image to maximize activation. The gradient trace algorithm is used here. X equal X plus eta multiplied by the partial derivative of ZIG with respect to X. Part 4 is this process terminates in the particular mode image X star when the image does not have any noise. This mode is considered the preferred input for the narrow. Finally, we will talk about SMV, silencing map visualization. Silencing map is a feature map that tells us how pixels in an image affect the result of image classification. Image-specific class silence visualization technique tries to find an approximate class scar function SCI. X is the input image with a label class C using first order talent expression. SCI approximately equal to omega Tx plus B. Omega is the value of the partial derivative xc with respect to x when x equal x0. And the first way should calculate the gradient of the standardized score in the correct classification corresponding to the image pixels. For each pixel in the image, this gradient tells us the magnitude of the difference in the score correctly when the fix changes slightly. When the calculating a silencing map, you need to calculate the absolute value of the gradient and then take the maximum of the 3-color channel. So in the final shape of the silencing map is HW as a grayscale graph of a channel. The image above is an image, and the following image is a feature diagram. And you can say that the bright part of the image below is the part of the neural network of interest. With light image processing, we can realize the silencing map with respect to the location of input pixels with positive gradients. That's all. Thank you. Thank you very much.
Thank you. That's all?
Yes, that's all.
Colleagues, do you have a question?
Yeah, yes.
Ovanes,
Yes.
Petrosyan, maybe you have?
No, I don't have any questions because I'm kind of
Плохо слышно.
sorry, I don't have any questions because I am involved in this research. So I don't have any questions. Maybe I can comment. I can comment on this. Maybe.
He's a co-author. Maybe he can make a comment, but he doesn't have questions.
Okay, I have questions. What is the performance of your approach? Did you estimate how is fast it works?
Using
New? Did you understand?
Just overview.
Question.
As far as I understood, it's just a review on the topic. They didn't implement or apply.
Okay. Maybe presenter has comments.
Because Dr. Petrosyan said that it's just review. So I think.
Okay.
Okay, thank you. The next presentation concerns iterative preprocessing methods for solving Hilbert matrix linear equations.
Zhu Yuan.
Yes, I guess that Zhu Yuan is presenter for this topic. I can see other authors.
Good afternoon, processes.
Good afternoon. You can share your screen.
Oh, okay.
Great, we can see it.
Good afternoon, processes and classmates. I'm Zhu Yuan, a student from Yan'an University. The subject of my speech today is SOR, iterative processing method for solving Hilbert matrix linear equations. This is divided into 5 parts. They are abstract, introduction, achievement display, summary, and reflection, concluding remarks. The first part is the summary. With the emergence and rapid development of electronic computer, science computing has become the third
scientific means parallel to theory analysis and scientific experiment in the development of natural science and engineering technology science. Numerical computation is an indispensable part of scientific computation. In numerical computation, the solution of linear equations is a very important problem. In addition, the final solution of many problems in mathematics, physics, and mechanics, and other discipline and engineering technologies is attributed to solving a linear equations group of one or some logic coefficient matrix. Therefore, solving large scale linear equations is the core of large scale science and computing. Page 4 present basic informations, divisions of membership, and research significance. In this section, our group understands the properties of Hilbert matrix and their basic principle and solving steps of SOR iterative method, and use MATLAB for calculation and analysis. Then we write the paper together and drawing the conclusion. This section describes the division of our number in our group. The research background of this paper is with the emergency and rapid development of electronic computer. In the development of natural science and engineering science, scientific computing has become the third scientific means parallel to theoretical analysis and scientific experiment. Numerical calculation is an indispensable part of scientific calculation, and in numerical calculation, a very important problem is the solution of linear equations. The research means of this paper is the solution of linear equations AX equal B, mainly include the direct solution method and iterative method. For linear equations with low order, it is convenient to use the direct method. Gas elimination method and Karamer's law are the most important method of equation solution. However, with the rapid development of science and technology, the scale of the problem that need to be solved is increasing. Iterative method has replaced the direct method, and because the most important method for solving large linear group. At this time, the convergence and convergence speed of iterative scheme become a very important problem and become the focus of attention. Of course, the non-convergence format cannot be used. Although the convergence is very slow, it is not only the waste of time and humans and machines, but also not necessarily able to solve the result. The practical application value is too small. The commonly used iterative method include Jacobi gas C and other
classical iterative method and SOR and other iterative method. This iterative method provides a fast and effective way to solve large linear equations, but these iterative methods are relatively harsh and all very cumbersome. In addition, when the spectral radius and of the iteration matrix is relatively large, especially close to 1, the iteration speed will be very slow, which greatly affects the timelines of the solution of the equations and thus limits this application. These following results will be present. First of all, we find the matrix in the above form is the famous Hilbert matrix, and the Hilbert matrix is an symmetric positive definite matrix and a famous Maybed matrix. Then we give the definition of SOR iterative method in this paper, which only shows its form as follows. These dimensions of the problem is gradually increased, and the equations are solved by LU iterations method, JS iteration and SOR iteration respectively. The calculation results are obtained, and the preliminary calculation are obtained by analyzing the results. This is a demonstration of the results of the model. This shows when the order of the morbid problem is low, direct solution can better find the exact solution. The iteration method has some errors. When the order of the variable problem increase, the direct solution will result in large errors. However, G method and GSSOR iteration method can still solve the guarantee certain accuracy. Choosing a pure repeat relaxation factors or iterative Vicent can speed up the convergence of the iterative solutions. This part is summary and the reflection. Through the researching and solving the problem, we have a certain understanding of the Hilbert matrix equations and their characteristic. Master and use the SOR method is in the classical iterative method and have a certain understanding and guess-sealed method and have a more systematic understanding of the characteristics of this classical iterative method. The use of MATLAB software is also more scaled. This part is concluding remarks. During this period of time, we not only learned to cooperate with each other, but also understand that to study one thing, we should not be afraid to hardship and the source. Only in this way we can achieve final success. This part is a reference.
Thank you.
Okay, thank you very much. Colleagues, do you have questions?
Yes. Thank you.
I would like to ask, do you know what size of Hilbert matrix is usual thing in practical applications? You have studied 20, right? The size of matrix you studied was 20.
All right.
Is it a usual size when making engineering results, or there should be metrics of size 100, 1000? Yeah, so do you think that the results for 20 will be the same for the sizes like 1000?
I think it can help people work more easily.
All right, I think you don't understand the question, but this was a good talk. Thank you.
Thank you very much.
Thank you.
Until next.
Alexei, do we have any question in a chat in YouTube? Alexei?
No, we don't.
Okay.
We only have some people who are watching and saying that one talk was all right. It was very nice.
Unfortunately, I can't see Menshikov.
He's here.
The next speaker.
Yes, I'm here.
In our list. Yes.
Yes.
Great.
Do you hear me?
Yes.
Okay.
Share
yes.
Screen.
You can share your screen.
Yes.
And start at 2:30.
Okay. Do you see the presentation right now? Okay. I'm Maxim Menshkov, and I would like.
Not yet.
Oh.
It's okay.
Oh. Is it?
Yes.
Oh yeah.
Okay.
Now we can see.
Okay. So I'm Maxim Menshkov, and I would like to talk about the systematization of abstractions for unified program language and environment support in static code analysis. The problem is that
Maxim, please share full screen.
Yes, it's full screen.
Now it's okay.
Максим, вы просто Zoom сверните, у вас серым светится часть экрана, когда вы включаете презентацию. Zoom сверните в одно окошко, и все будет нормально.
Максим вообще завис, наверное.
Maxim, are you here?
visit.
Он переподключился.
Hello. Somehow Zoom is not really stable for what reason. Let me start it. Okay. Do you see the presentation? Do you see the presentation right now?
Yes, we can see.
Okay.
Yes, it's okay.
I'm Maxim Menshkov, and I would like to talk about systematization of abstractions for unified programming language and environment support in static code analysis. The problem is that static analyzers gradually become useful as components of complex development technologies. Complex tools support analysis from start to the end of R&D process, during project input, dependency analysis, debugging, and so on. So it's a bit more than current integrated development environments can propose. Such tools require unified support of programming languages, operating systems, tool chains, and etc., which is still an architecturally hard problem. So the question is how to make or choose abstractions for efficient analysis in such environments. We propose to tackle the problem accordingly. First, we'll define what do we work with, then we'll classify abstractions, then choose the most viable abstractions, and then we propose the schema for real-world analysis, and we test it. So, and then we assume that the problem is hopefully done. The definitions are an environment. An environment is a unique combination of a language, compiler, runtime operating system, CPU, and other parameters. An environment comprises properties. The term abstraction is used in this research on two occasions. First one is a set of properties and methods to handle a specific environment. And a second definition is a function that gives a numerical value to a set of properties, or we can call it an environment. Our classification principles are based on two categories. First one is the visibility of abstraction, and the second is an importance of abstraction. We'll start with the visibility of abstraction. The explicit abstraction is the abstraction which is directly seen by the user. It's encouraged by user or written, or in some way, the details of the abstraction are defined in the code itself, while implicit abstractions are defined by the language, by compiler, and these details are not seen by the user. There are four categories in our understanding. First is implicit translation actions. It's about mapping types from and to internal objects. It's about translation of expressions from and to internal objects in intermediate representation language, which is used in the static analyzer. And it's a translation of control constructions, such as branches, loops, and so on. For example, we can handle such constructions to make a control flow graph. The category of explicit semantic abstractions handles lookup and storage of object and type data. For example, in C++, the namespace notion supports storing objects quite in a quite unified manner, which can be reused in other languages as well. Then implicit semantic abstractions. Those are about primitive data type operations, such as how do we store the value in the variable, for example, little endian, big endian, and so on. And the factual type structure support. As you know, C and C++ may reorder fields, may insert alignments, and may pack structures in any way the compiler decides is a good thing. So the factual type structure support is really important. And the fourth group comprises both explicit and implicit properties. We can't really designate between implicit and explicit here because it's quite questionable. So we'll just keep it as a mixture of both types. Language environment semantics, execution environment semantics, and characteristics of execution environment really have influence on how the static analysis of the program is performed. For example, if we take a different language runtime, we'll see a different behavior of functions. So we have to make abstraction for it. And the program in, for example, in real Windows or in Wine, we will have a differently functioning functions as well. So it's also have to be abstracted away from the user and from the static analyzer. Then we can ask the question, what would be an ideal abstraction? If we just take all properties we know, which we call Pmax on this slide, that will mean that our analyzer is pretty much complete. But it will take very long to execute. It will it will take maybe years to finish on a big project. So it's not feasible. If we take an intersection of properties, we'll easily find out that our analyzer can't do anything good. We'll see that it may handle only very little properties which are not really important for the user, and such an analyzer would be useless as well. So we should select some optimal method of choosing properties which will make up an abstraction. To do that, we introduce a notion of mandatory and effective properties. Mandatory properties are the properties which we would like to support in the analyzer directly. For example, if we want to catch memory leaks in the code, we call all properties which make up a memory leak property as mandatory. And if we speak about environment properties such as the behavior of operating system, for example, under out-of-memory condition, we'll call such properties effective ones. These effective properties are called this way because they are mentioned in rules and they actually contribute to the result seen by the user. So the optimal abstraction would comprise the mandatory set of properties, which matches P minimal from the previous slides, an effective set of properties, which is still a combination of P min and P max. But if we create some function for this abstraction, which gives some numerical representation of the set of properties, then to find an optimal set of properties, we can just find an abstraction, or we can just find the sets of properties which differ for at least two environments. And that would be a simple optimality criterion for abstraction property selection. Of course, it doesn't mean that this set would be complete. but at least it would let us distinguish between different environments and will have a positive impact on the quality of analysis itself. The practical meaning of the classification consisting of explicit and implicit properties and effective and mandatory abstractions is that we can put effective abstractions to extension models and put mandatory abstractions to the core. For example, if the abstraction is important enough for us to put it in the core, that means we can compile it and have the biggest performance possible in this situation. But if the abstraction is not that important, it is seen in the real problems, in the real programs fewer times, and our developers can write extensions to it without compilation. That means we can just put such abstractions to extension models and have less overhead related to compilation, for example. The second good point is that we can make explicit abstractions more verbose, and implicit abstractions may have fewer details preserved. It's important because when we want to show where did the problem occur, or what was the trace in the specific point, or some other properties important for the user, of course we want to preserve all these details, but they take space, they take time, they take CPU time, which is most important, and the analysis with so many details will also take ages to finish. But if we classify some abstractions as implicit, we can avoid saving these details for them, saving time, CPU time, and memory. And the last practical meaning is that this classification allows choosing a set of properties to form a good abstraction. To do that, we can simply choose properties which are mandatory for target solving method and which are actually used in the roles. Then it's more or less optimal. Of course, there can be different selection in different needs. This approach had been tested in our static analysis called EQUIT. The following abstractions were implemented. They include compiler, CPU, language semantics, namespaces, type databases, operation system semantics, contextual semantics, and execution models. They belong to different types, such as explicit translational, explicit semantical, implicit semantical, and or mandatory or effective, or really a lot of possible types. What we observed is that the performance improved by at least 30%. This result has been accomplished by moving important abstractions to the core and making them compile. Obviously, this separation makes clearer architecture of the whole solution. And we observed a quick implementation of new environments. For example, it took us years to make perfect C support in the beginning, but when we got tasked to add a C++ support, it took us a lot less time, just some months to finish it. Also, this scheme inherently shows where to put extension points to analyzers, which is also important for the developers. The problems are that sometimes it's hard to classify an abstraction. We can avoid it by just calling all abstractions, by just calling them effective rather than mandatory. So then we'll profile the tool and find out which rule would work best when compiled. And the architecture to support abstractions is hard to implement correctly from the first try. It's clear, and as we said, it took several years to do for C, which is a much easier language than C++. And for C++, we had some part of architecture done, but and even though we had some problems implementing it, of course, it was way easier than it was for C.
Maxime, it's time to finish the talk very quickly, very quickly.
Okay. Conclusion is that systematization of abstractions for unified programming language and environment support was proposed. The method to find an optimal set of properties for the user in models is proposed. And the approach had been tested in a real-world analyzer where it had shown the advantages despite minor issues. Thank you. Any questions?
I'm afraid we don't have time for questions. Thank you for your presentation.
Thank you.
The next speaker.
Next speaker.
Yes, okay.
Hello, Professor. Can you hear me?
Hello, yes, we can hear you. You can start. You're welcome.
Okay, I will start. Wait a moment. Hello, teachers and students. I'm Zhang Jianpeng, the project reporter today. And the project I report today is image fusion based on transformed domain. I will introduce from the following three parts. The first part is the purpose and the significance of the study. As we all know, images are the basis of human vision and important information carrier for people to express ideas and share feelings. Images are used in photographs, paintings, sales, and technology. In our daily life, we can always feel the special charm of graphic images when we face pictures and text. But the untreated image cannot fully express its content. However, the image after image fusion processing has more accurate and reliable characters and strong anti-transformation. And it makes the picture more clear, rich, and comprehensive. Therefore, the ultimate goal of this study is to improve the image fusion effect. That is, the image fusion process with clear synthetic images, richer details, and less computation. The second part is our research program. The image fusion process based on transformed domain method is to fuse two or more images by digital image fusion technology. Fourier transform is used to transform the image from spatial domain to frequency domain, and low-pass filtering and high-pass filtering are processed. Then the image is transformed from frequency domain to spatial domain by inverse Fourier transform for image reconstruction and image enhancement. The overall research scheme of the image fusion method is shown in the image. The filter and image fusion technology are used to complete the adjustment of software and hardware. The image input, image registration, image pre-processing, and image fusion are completed. Finally, the image reconstruction is converted to time domain and then output the image. Cross-correlation method and image registration method based on MATLAB transform domain are studied. The obtained two kinds of image data are denoised, enhanced, corrected, segmented, and the registration feature points are selected. The data format and image size are unified, and the resolution of the original image space and spectrum are improved. The three-dimensional reconstruction and the display of space-void images are carried out, and the mathematical model is established according to the characteristics of the target. The image filter method realized by MATLAB is currently the Fourier transform filter method. The time domain signal is decomposed into the sum of sinusoidal signals or cosine signals with different frequency by Fourier transform. In other words, Fourier transform provides another perspective to observe the image, which can transform the image from the gray distribution to the frequency distribution to observe the image. At this time, it is necessary to use the corresponding filters such as the Edo filter, the Gaussian filter, and perform different operations in the frequency domain to achieve the expected image processing effect. Then the image is reconstructed by inverse Fourier transform to achieve image fusion. The last part is our research results. First of all, please look at this picture. I'm sure you know Einstein, a famous scientist, but please keep a certain distance to see this picture again. Perhaps I shake the picture after watching. Now the smiling Mariam Mulu is showed in the picture. Why? Then I will explain to you. Based on the principle of Fourier transform, MATLAB is used to simplify the image filter process. The image of Einstein is filtered to retain its high frequency component, and then the Mariam Mulu's image is filtered to retain its low frequency component. The frequency spectrum of the image is divided into high frequency component and low frequency component. The high frequency component represents the mutation part of the image, that is age information. The low frequency component represents the gentle area of the image, that is contour information. When the distance is close, we can easily see the high frequency component. When the distance is far, the image we see is dominated by the low frequency component. Therefore, after the filter of the two filtered images, there is the result that the same image sees two people at different distance. Please look at this picture again. What we see is actress Mariam Mulu, but please wish this picture when you keep a certain distance. I will show you the picture after I reduce it. Now, what we see is Einstein. A filter of the same images have different results. In this image, Einstein's image is filtered to retain its low frequency component, and then Mariam Mulu's image is filtered to retain its high frequency component. So we got an image of Mariam Mulu in close view and Einstein in far view. Now, the math code used in image filter is shown. This kind of image filter method is based on the Fourier analysis, which can make different images fused together, and it is convenient to obtain the effective information of multiple images in a limited map. As a global trade, Fourier transform has certain limitations, but its inverse transform is easy to find. And the application of MATLAB makes this kind of image fusion method easier to achieve. Thank you for watching and listening. Next, please ask a question.
Thank you for your presentation. I have a question. How you estimate quality of generative picture? How you estimate good result or not good result?
When we say the high frequency component represents the mutation part of the image, that is 就是 age information. The low frequency component represents the gentle area of the image. That is counter information. And the ultimate goal of this study is to improve the image filter effect. The image filter process with clear synthetic images, richer details, and less computation.
Thank you. Did you look at generative adversarial network, GAN network? Do you know what is GAN? Generative adversarial network. Do you know?
Can you repeat it? I can't understand what you say.
Do you know what is generative adversarial network? Look at the chat again. Look at the chat.
Can you hear me?
Yes.
Oh, wait.
Now I sent you on China language.
GAN is a special neural network architecture for picture or tabular data generation.
Oh, generation.
Look at chat. I sent to you hyperlink to Wikipedia.
Sorry, I don't know. I can't push out.
I recommend you look at this approach and using this model to your task. I think you can get a good result and interesting result.
Thank you, Professor.
Look at the chat after our discussion. Questions?
No, I think we have to go on.
Okay. Thank you very much for
Thank you for presentation. The next speaker is Kyong Lee.
Hello, Professor.
With presentation.
Hello.
Yeah, hello. We can see you, we can hear you. Please share your screen.
Okay.
Great. Okay, you can start. You're welcome.
Hello everyone, my name is Li Chung, and my report is about single agent reinforcement learning review of model-free approaches. The person who completed the work with me was Dr. Sun Qiushi, and I would like to thank my mentor ONS Peterson for his guidance on our work. And there are two parts in my report. First one is reinforcement learning solving method, which is based on model free. It's about Monte Carlo method and temporal difference learning. The next one is reinforcement learning algorithm. There are three in total, namely Q-learning, SASA, and policy gradient algorithm. This is a summary of reinforcement learning algorithm under different classification. The main components of the reinforcement learning individual are policy, value function, and model. The model-free individuals do not view how the environment works, but focus only on value and or policy function. The model-based individuals are trying to establish a model describing the process of environmental operation, which can guide the updating of value or policy function. The classification about reinforcement learning individuals, we can divide two parts, value-based and policy-based. Value-based only on value function. In such individuals, there are value estimation function for states, but there is no direct policy function, and the policy function is indirectly obtained by value function. The policy based only on policy, such behaviors are directly generated by policy function, and the individuals do not maintain an estimation function of the value of each state. And we have actor critical. This individual has both value function and strategy function. The two combine to solve the problem. The first one we talk is the Monte Carlo method. It's also called the statistical simulation method, which use random number to solve calculation problems. Different from general dynamic programming algorithm, Monte Carlo method looks at the problem from a new perspective. In short, it focuses on how many samples do I need from the environment to distinguish the best policy from the bad policy. Monte Carlo strategy evaluation uses the average obtained value of multiple episodes instead of the state value function. And this is a Monte Carlo model about a blackjack game. The highest point of the value function is the best strategy. Next is a temporal difference algorithm. The temporal difference algorithm inherits the advantage of dynamical programming and Monte Carlo methods to predict state value and optimal policy. TD prediction is the same as Monte Carlo method. There are still two parts of calculation. The first part is TD prediction, and the second part is TD control, whose purpose is to obtain the optimal policy.
TD prediction is to calculate the state value in terms of calculation time. TD faster than Monte Carlo method. According to the formula, TD only needs to wait until it jumps to the next state to know the state value of the current state. However, the Monte Carlo method needs to wait until the end of the entire experiment to get the current state value. Because when TD calculates value, it's calculated based on the current state and the next state. So there is a deviation, but the variance is small. And in contrast, the Monte Carlo method is unbased, but the variance is large. The next part we will talk the Q-learning is a of-policy algorithm. Q-learning is a value-based algorithm in the reinforcement learning algorithm. And QSA is the expectation that taking action A at a certain moment in the S state can obtain benefits, and the environment will respond accordingly to the action of the agent return reward R. So the main idea of the algorithm is to construct state and action into a Q table to store the Q value, and then select the action that can obtain the greatest benefit based on the Q value. Then we talk about SASA algorithm. SASA is also a very important algorithm in reinforcement learning. This algorithm and formula are very similar to Q-learning, but Q-learning is off policy and SASA is on policy. And the decision-making part of the SASA algorithm is the same as that of Q-learning, and all decisions are made in the form of Q tables. And in the Q table, the action value with a large value is selected and applied to the environment in exchange for rewards and punishments. That is, the calculated Q value is used as a basis for selecting the action. The difference between the two is that the behavior update criterion is different. This picture is about the application of the taxi problem. It uses the algorithm of Q-learning. R, Y, J, B are 4 different places. The rule of the game is pick up passengers at one place and then send them to another designated place. You can get 20 points for completing a successful passenger transfer. But for every step of the taxi, you will get 1 point dedicated. In addition, 10 points will be dedicated for sending passengers to the wrong place. The yellow square represents the taxi. Vertical line represents wall. The blue letter represents the location to pick up passengers, and the purple letter represents the location where passengers get off the taxi. When there are passengers in the taxi, it turns green. This picture on the left is the reward convergence when alpha equals 0.4, gamma equals 0.999, and epsilon equals 0.017. The picture on the right is the result of the error between the old and new table. These two sets of graphs are the results when alpha takes different value and it uses the SASA algorithm. It can be seen that when the alpha is 0.3, the simulation result is very similar to the result of the Q-learning algorithm, and it can be seen that when the alpha value becomes larger, the optimal solution becomes small, and the error becomes larger. The fourth group is the result when epsilon is equal to 0.008. When the epsilon value becomes larger, then the optimal solution becomes small, and the fluctuation is particularly large, and the error becomes larger. And the fifth group is the result when gamma is equal to 0.3. When the gamma value becomes small, the optimal solution becomes small, but it's stable and the error becomes small. The next one is about policy gradient. Policy gradient is used as a part of the strategy output part of the neural network. In some case, it can be either a distribution network or categorical network. They are all applicable to the continuous action space. Since the reinforcement learning algorithm based on policy gradient is on policy, there is no need to introduce a gradient algorithm like the DQN algorithm. The algorithm of the policy gradient class updates the parameters of the policy network through gradient calculation. So the objective function is directly designed as the expected cumulative reward. There are many ways to express this expected value, which corresponds to the different calculation. The method of the loss function by different specific algorithm. That's all. Thank you for listening. Hello.
I have questions.
Okay, thank you.
Yes.
Did you apply algorithm on slide 4th on practice or not? Did you implement this algorithm? Can you open 14? Yes. This slide. Did you implement it or not?
Oh, sorry. For now, I'm not applied about this algorithm.
And result on previous slide. Previous slide. Open, please. Yes. It's your result, or you take this result from paper and show us?
It's about my tips, my group and result.
Okay, thank you.
Colleagues? I can comment here, maybe I can comment. So all these results, they come from the papers and online courses that the students now are using or doing. And these are the simulations results that they have obtained. So maybe she did not understand your question. yeah, these results she implemented and in the group with her students, and not just show pictures from papers. No, of course.
Yes. Oh, thank you.
Okay, thank you. Any questions?
No. So thank you very much. Now we have a break for 30 minutes. So at 15:45 we continue our section. So have a good break. See you soon. Okay, dear colleagues, I guess it's time to continue our section. The next presentation is discussion of potential application of axiomatic choice theory in business from Sachkov and Sherbakov.
Yes, can you hear me?
Yes, you can share your screen.
Okay, just a moment, please. Okay. One moment.
Okay, great. You can start.
Okay, thank you. Greetings to everyone watching, to the organizers, and I would like to thank the organizing committee for this opportunity to participate in this conference. And I will be presenting the talk on discussion of potential application of axiomatic choice theory in business by myself and Gleb Alexandrovich Sherbakov, both of St. Petersburg State University, Faculty of Applied Mathematics and Control Processes. So let us begin. Well, initially, I would like to make some remarks of general nature. When we are in the process of mathematical modeling, we always have to remember several things. The main of them is to keep the balance between practicability and accuracy. So if your model is too vague or too inaccurate, it's bad. And if it's too difficult to to perform any actual calculations with it, it's also bad. So the balance is important in that case. So now on to the main topics of discussion of this article, of this presentation. First of all, we'll look at axiomatic choice theory, try to understand what it's all about. Then we'll discuss some potential applications, namely in business, and look at some ongoing problems and broad strokes of potential solutions. So when we are talking about the multi-criteria choice problem, which is basically you have several things you have to choose from, and they are characterized by their criteria, which are represented numerically. Usually what people did was to assign sums, assign weights to each criteria, and then just sum them all up, and the one with the highest weighted sum was declared to be the best. This approach is valid, but it has several drawbacks in that it's not very rigorous, mathematically not very strict, and you also have to consider that oftentimes you don't know whether you can actually use this approach in this particular case or not. So at our faculty, there is an axiomatic approach to this problem being developed by professors Nagin and Baskov, and it has several advantages over the classical one. Namely, it is mathematically strict, based on a couple of naturally arising axioms, from how people choose in real life. And you can also, despite its strictness, you can extract actual computational algorithms from it without much difficulty. So we have to discuss some definitions to know what's going on first. So we have three main things in choice theory. X is a set of feasible alternatives, basically things we choose from, like mobile phones, cars, apartments, etc. Then we have a vector criterion, which is a n-dimensional function where n is the number of criteria, which is basically, well, we evaluate certain qualities of things from set X, like price, weight, etc. And we also have a preference relation on X, which basically allows us to compare two things from the set X. So if a person prefers one thing over the other, then they are in this relation. And to postulate the problem, we can do it this way. So given X, F, and the preference relation, we have to find C of X, the set of selectable alternatives. And this is basically things we choose from set X as a solution to our problem. We have a lot of things, but we have to choose only several. And C of X is these several things. Since the nature of things in set X is arbitrary, it's easier to work with vector criteria attributed to these elements of X. So we conduct a process which allows us to go from X, F of F, and the preference relation on X to Y and the preference relation on Y. And this allows us to compare vectors which are numerical and which are easy to work with, unlike some abstract elements of the set X. And since the theory is axiomatic, we will now briefly discuss them. So if Y1 is preferred over Y2, then we don't choose Y2. The preference or relation on Y is transitive, which is, well, allows us to escape from loops where the first thing is better than a second is better than a third, but then first is worse than a third. This prevents it. Then there is the compatibility with each criteria and invariance with respect to a positive linear transformation. Then we move on to the central definition of a quantum, which actually allows us to compare things and to extract the preferences from the decision maker. So basically, we present the decision maker with two elements of set X and ask them to compare them. And from that, we extract the quantum. First is the elementary quantum, where there are only two criteria, and basically well, the definition is muddy kind of and hard to understand at first glance, but actually it's just it means its meaning is simple, where the decision maker is prepared to sacrifice omega j of criteria fj to get omega I of criteria fi. And this is the formula we use to recalculate all the other criteria vectors to progress with our selection process. And the general quantum is basically the elementary quantum, just without the restriction of only two criteria. And here we have not just two criteria, but several. So we move on to sets. And the meaning is the same. We are prepared to sacrifice omega j start of fj for every j in B. So in B, we have all the criteria we are ready to sacrifice. And in A, we have all the criteria we are ready to gain. Well, this just allows a lot more flexibility in which problems we could solve with this. So now we move on to potential applications. Imagine a company which tries to push a product to a market, and they want to decide which parameters of the product are more important than the others. So we create a kind of a feedback loop system where we extract quanta via a mobile app, for example, from our customers. They choose their preferred products of the list we provide them, and we get the information we need to optimize the qualities of the product to their liking. We can work with wide groups of customers, or we can tailor our products to the preferences of individual customers. Next, we can also use it to, well, in air quotes here, sort lists of things. Imagine you have like 100 smartphones, and we want to choose several, or to have a list like top 10. So we can use it in tandem with some recommender systems for improved prediction quality. So first we run the list through the recommender system, we get it sorted, and then we present it to the decision maker, and with our approach we refine it further. There are some problems with this approach, perhaps I'll mention them later. Also, if we have an access to the search history of the user, we can extract the so-called passive quantum from it, supposing that the most searched item of this user is the one he would choose over all the others. So basically, if he searches for that one smartphone all the time, that means he prefers it to all the others, and we don't even have to extract the information from him directly. We just use this to sort the list again with less interaction and in a more automated fashion, let's say. There are some problems also. The first of them is which pairs of feasible solutions should we present to the decision maker. Since different pairs yield different results, we can, if X contains 100 items, for example, one pair can reduce that in one go to like 50, and the other can reduce it from 100 to 99. So obviously, it's in our interest to present the pairs which allow us to, well, to filter out the most items. There is no definitive answer yet. There are only some, some ideas waiting verification. For example, we can present such pairs that their sum of absolute differences in criteria is the highest out of all of the pairs, or we can just limit this to a single pair of criteria, a single criteria for the pair of vectors. So for example, if we have two phones which are the most diverse in price, so one costs 100,000 and the other costs like 500 rubles, then by presenting this pair, supposedly we are going to filter out more items than we would have otherwise. But once again, this is pending verification. Also, when we are recalculating vector criteria vectors of the items, we we employ matrix multiplication, and the matrices, they have rapidly increasing dimensions, which is a well-known problem, where past a certain point you just don't have enough processing power. In generally, you don't have enough processing power. So what we can do is to split the list in parts and process each part individually, thus limiting the dimension growth. And then from the winners of each category, we can then group them up again and process them once again, and this will reset the dimension and partially solve the problem. Once again, this is the proposed solution, not the ideal one. What did we hopefully accomplish? We have familiarized ourselves with the axiomatic choice theory, considered some potential applications, problems, and solutions. What I would like to highlight is that the axiomatic approach is strict at its core. based on axioms and mathematically sound, but it still provides actual computational algorithms and can make, we believe, the decision-making process easier and more accurate overall. So what are the further research directions? What can we do next, and what are we planning to do next? We can consider employing fuzzy quanta, which are
Okay, thank you very much. Unfortunately, it's time to give a word to the next speaker. It was very interesting. Unfortunately, we can't ask any questions. But anyway, thank you very much for your interest and presentation. So, okay, the next topic is modeling of distillation column without measurement data.
Hello, can you hear me and can you see my slides?
Yes, great, we can hear you, so you can start.
Well, hello, ladies and gentlemen. My name is Jan Schasberger. I'm a student of the Karlsruhe Institute of Technology, and I'm pleased to present you our contribution on modeling of a distillation column without measurement data. This work was created within the context of master thesis at the Institute for Automation and Applied Informatics. I'll start with our motivation for the work and give you a short process description before I present you the model equations and present some results. Distillation columns are frequently used in industry for the separation of liquid mixtures. For control design purposes, it is standard to use empirical models based on measurement data of step experiments. Unfortunately, this data is not always available for several reasons. For instance, for reasons of confidentiality, or because of costs, if some important sensors are missing, or because of technical or safety limitations. Thus, even in our case, no measurement data is available, so we decided to develop a first principle model of the distillation column. This distillation column is used for the separation of N-methyl-2-pyrrolidone and water, which arises, for instance, during the manufacturing of batteries. This material separation is difficult to control because of large temperature gradients within the distillation column. And so the current control concept of the plan does not show satisfying behavior. In the right side of the slide, a simplified scheme of the distillation column is depicted. There are further planned components which are not displayed for reasons of clarity. The distillation column consists of head, feed, and sump, and 2 packings. The liquid, which is collected in the sump leaf, is continuously conveyed out of the distillation column, where this flow is split into 2 partial flows. One flow leaves the plant as a product flow, whereas the second one is evaporated and re-enters the distillation column. In the middle, 2 feeds enter the distillation column. The liquid one streams together with the liquid, leaving the upper packing into the lower packing, whereas the gaseous feed streams into the upper packing. In the head of the distillation column, the liquid, the vapor leaves the distillation column towards the condenser, and the liquefied water is collected in a tank. From this tank, 2 flows are taken, a second product flow and the reflux. The reflux is fed back to the distillation column's head. When modeling a distillation column, an equilibrium stage approach was used. In doing so, the continuous packing is divided into discrete theoretical stages using the height equivalent to a theoretical plate. The vapor and the liquid at a theoretical stage are assumed to be in equilibrium. At the right side, 1 theoretical stage is depicted. Each stage I is assigned an amount of substance per component, denoted with J, the molar fraction of both components in the liquid and the gaseous phase, as well as a temperature and a pressure. Moreover, there's vapor exchange, and liquid exchange between the stages of the packing. The vapor streams from the bottom of the column towards its head, whereas the liquid streams from the top towards the bottom. The material exchange equations used in this work are based on a publication in which good agreement between the simulation results and measurement data of a simulation, measurement data of a real column was shown, but we introduced several modifications. The vapor is calculated in this work with this equation, which is based on the energy balance of a theoretical stage. And we introduced an additional heat loss term consisting of the heat transfer coefficient, the outer surface of a section, and the temperature difference to the ambient. In the case of the liquid flow, we replaced the original amount of substance-based one with a volume-based one, since the substances used in our distillation column have much different molar volume. This equation can be illustrated by means of a tank, which has an outlet which is located above the bottom, so we obtain a static and a dynamic holdup. In the following, at this slide, further important model equations are presented, where the focus is on the distillation column. The composition of the gaseous phase is calculated using Dalton's and Raoult's law as a function of the equilibrium, vapor pressure, the pressure in the distillation column, and the composition of the liquid phase. The temperature is calculated using Raoult's law by solving this equation with respect to the temperature, where the equilibrium vapor pressure is calculated using a strongly nonlinear equation where A, B, C, D, and E are substance-dependent parameters. In addition, one material balance per component is evaluated at each stage. So we obtain a large system of coupled nonlinear equations. In the following, I will demonstrate the influence of the parameters on the system behavior, starting with the static holdup. In the figure, the temperature at a potential measuring point in the lower packing is depicted for an increase of the liquid feed on the left side and an increase of the heating steam, which increases the amount of vaporized liquid in the sump at the right side. We can see that an increased holdup does hardly change or almost don't change time until the increase of the liquid feed affects the temperature in the lower packing, but it decreases the temperature drop rate slightly, whereas the temperature rise time in case of the heating steam decreases strongly. If one considers the dynamic holdup, we obtain a different result. We can see that the time delay increases strongly, whereas the temperature rise time is only slightly decreased. The last parameter to be examined is the heat transfer coefficient. In the left figure, we can see the temperature in the lower packing for an increase of the heating steam for the 3 different values of the heat transfer coefficient. When interpreting this figure, one needs to know that the temperature at a theoretical stage is limited to the interval between the boiling temperature of the low boiling and the high boiling component, which are in this case 304 and 380 Kelvin. So we can see that in case of the red and the blue curve, the system comes to rest, but not in the case of the black curve, because it reaches the maximum temperature at this stage, and so the temperature profile inside the distillation column keeps moving towards its head, which can also be concluded from the right figure, where the temperature at a temperature a few stages above is depicted, and we can see that after a certain period of time, in case of the black curve, the temperature starting to rise and again reaches its maximum. So the temperature profile is still moving. Since we wanted to design a control concept for the distillation column, we need to reduce the model's complexity. since the original model has more than 100 states. And so at first we performed a structural reduction, and this means that we neglected the dynamics of system parts, which showed an almost constant behavior in the operating range, and also neglected dynamics which are much faster than the overall system. In doing so, we were able to reduce the number of states to 80 states, and afterwards we applied a Taylor linearization and applied a reduction of order using the method of balanced truncation, and finally we obtained a system of 12 states. At last, I want to show the results of the model simplification in the closed loop using the heating steam as the manipulated variable. And this figure shows the system, the control area for an increase of the liquid feed and the change of the manipulated variable. In the figure, the curves for the nonlinear, the linear, and the linear system of reduced order are shown. We can see that all three curves show relative good agreement, and especially the static value, the static behavior is almost identical in all three cases. We obtain an even better result if you consider the reflux into the distillation column's head, which can be explained by the fact that the absolute change is smaller when considering the reflux, and change of the reflux by 5% instead of a change of the liquid feed by 5%. Also in this case, we show good agreement and the static behavior is almost identical. To sum up, we developed a structural model of the distillation column, whose behavior can be adjusted with a small number of parameters with a physical interpretation. So we see potential to adjust the model's behavior only with practical experience from operators and qualitative observations. And as future work, we want to develop a new control concept to improve the plant's behavior. Thank you for your attention. Are there any questions?
Thank you very much for your presentation. How are you going to use your result in future work?
We want to adjust in cooperation with our project partner the model's behavior to as close as possible to the real behavior of the plant, and then investigate which disturbance, which input has a great effect on the system behavior, and give recommendations for a better control structure to maybe which input needs to be used, or on which disturbance one needs to pay a lot of attention. Yes.
Okay. Thank you very much. Any questions? Okay. Thank you very much. The next presentation is Alexei. Could you please?
Hello, maybe next one is me.
Yes,
right?
yes, yes.
Yes. Oh, yeah. Okay. Yes. Can you see my screen?
Yes, please.
Yes.
Yes. Okay. Hello, everyone. My name is Lin Hong, and my report is about single-agent reinforcement learning, review of model-based approaches. And the second author is Dr. Sun Qiushi, and my supervisor is Ovnas Peter Rosian. There are two parts in my report. I will first introduce the overview of reinforcement learning and then introduce the dynamic programming method in reinforcement learning solving method. First, let's look at how reinforcement learning works. Cat is an agent that is exposed to the environment. In this case, is your house. An example of a state could be your cat sitting, and you use a specific word in for cat to walk. Our agent reacts by performing an action transition from one state to another state. For example, cat goes from sitting to walking. The reaction of an agent is an action, and the policy is a method of selecting an action given a state in expectation of better outcomes. After the transition, they may get a reward or penalty in return. Then let's consider that Markov decision process. Markov decision making has three requirements. Firstly, it can detect the ideal state. And secondly, it can try multiple times. And thirdly, the next state of the system is only related to the current state information and has nothing to do with the earlier state. And it's also related to the current action taken in the decision-making process. In reinforcement learning, the agent and the environment are always interacting. At each time, the agent will receive the state from the environment based on this state. The agent will take action, and then this action will act on the environment. So the agent can receive a reward, and the agent will reach a new state. Therefore, the interaction between the agent and the environment is actually a sequence. So why is reinforcement learning so important in generally? The main reason why reinforcement learning has received widespread attention at the moment is because it's suitable for many application scenarios and does not require a lot of expensive label data like supervised learning. Compared with supervised learning, the way of thinking and specific algorithm of reinforcement learning can better describe the process of human learning, which is more similar to the behavior of living subjects. Many researchers believe that reinforcement learning is likely to lead to strong. The artificial intelligence approach also adds to the charm of reinforcement learning. It's precise because of this characteristic that reinforcement learning has received so much attention today and has become such an important research direction. So this is the algorithm flowchart of reinforcement learning, and I report is this part. Let's talk about the dynamic programming method in reinforcement learning. Policy iteration includes policy evaluation and policy improvement. The policy evaluation itself is also an iterative operation. Every time a policy is evaluated, the initial value of the value function is the value function of the previous policy. This usually significantly improves the convergence speed of policy evaluation. The action is selected according to the strategy time during policy evaluation, and the action is selected according to the max Q based on value function of convergence during policy promotion. The policy obtained by policy promotion is not necessarily the same as the previous policy. Policy iterations usually require only a few iterations to converge. And then comes the value iteration part. Analyzing value iteration from the perspective of policy iteration. The value function update can be divided into two steps. The first is policy improvement. The policy is promoted according to the value function before the update to obtain a greedy policy. The second is policy evaluation. According to the greedy policy, select the value corresponding to the greedy action A instead S, and update the value function corresponding to S. Unlike policy iteration, in a value iteration process, the algorithm does not give a clear policy, and the value function obtained during the iteration process does not correspond to any policy. Although value iteration does not require policy participation, it still needs to know the transition probability between states. That is, it needs to know the model. Then let's look at an example. This is a small game, Frozen Lake in Gem. Frozen Lake is state space that is completely visible, and the transition law between states is relatively clear, and there are MDP problems that can be modeled on. The state space of the Frozen Lake game is very simple. It's a 4x4 matrix with a letter in each position. S represents starting point, F represents the frozen surface, H represents the hole, and G represents the goal, which is the end. When the agent is on S or F, it's safe, but 1 point is detected when it reaches H, and 1 point is added when it reaches G. The action space of the game is also very simple. There are only 4 options, which are 0, 1, 2, 3, which represent movement in 4 directions. 0 is moving to the left, 1 is moving down, 2 is moving to the right, and 3 is moving up. But but we notice that when the agent reaches the boundary, it cannot no longer move in the direction of the boundary, and it's likely to stay still or move in other directions. Therefore, this figure is the result of policy iteration. We can see it converges at step 7. And this figure is a result of value iteration, and the other picture is the arrow between new and old value table. We can see it converged at iteration 1373. So the above is all the report. Thank you very much. Any question? Hello?
Hello.
Yeah.
Do you have questions, colleagues? Your report is overview. Yes, report. Did you implement maybe anything algorithm and apply in a real case maybe?
No. I'm sorry.
No? Only theoretical.
Yes. It's just all like overview. Yeah.
As far as I understood, Alina Boyko follows your presentation very careful, and she has some questions. Maybe I'm not right.
Me?
No, Alina Boyko. She follows presentation very carefully.
Thank you, Alexander. And thank
hello?
you for hello. Can you hear me?
Yes.
Yes, we can hear you.
Yeah.
And so it's very interesting presentation. Thank you. And also, I don't have any questions. Very interesting. Thank you.
Okay. Thank you very much.
Colleagues, do you have questions maybe? Okay, the next presentation.
Are you sure? Maybe we have to wait to be in timetable.
Or we could start 5 minutes earlier and finish 5 minutes earlier.
The next presenter is Su Shimai.
Yeah.
Share screen. Okay. Share screen.
Should I start now or just wait a little?
Share full screen, please.
Okay.
Thanks.
You can start.
Okay. Good afternoon, professors, colleagues, friends. My name is Su Shimai, and the courser and also my supervisor is Dr. Ivan Bleknov. And we are very glad to present our work in this conference. The title of our work is Neural Network Method for Message Analysis in User Discussions on YouTube. I will introduce our projects mainly from three perspectives: the background, the framework, and the implementations, and the experiment. The background. So nowadays, with the development of network and also the broad usage of modern device, it's quite. I mean, it's just a piece of cake to let the news or videos to be widespread all around the world, maybe just within a second. And we are more interested in the feedback of these videos or news which occurs in the public. And so we are, based on such consideration, we are proposing a solution for the journalists, for the government or companies or relative parties who have interest in the sentiment analysis of the public. And our solution, starting from data coding to data processing, language model for sentiment analysis, and the summarization. And for the first part, data coding, we select YouTube, which is one of the most representative platform, social network platform, as our source of the data. And we constructed two different methods, Selenium and YouTube data API, to grow the data from YouTube. And as we all know, then Selenium is a web test tool, which is compared with the YouTube data API. Selenium doesn't have the robustness or other, just lots of drawbacks. And why we still propose Selenium this solution? Because of the we are considering because if this solution is applied in other scenarios, they may not able to apply the API service. So in this case, then Selenium can be applied. And so in this case, we propose, we opt for YouTube data API. And in order to build the association with the Google server, we need to apply for the developer key before sending the request. And we just need to declare what kind of data we want to get, and the server will get the request and compare the developer key and the relevant information and send us the data. And after obtaining the data from YouTube, commonly there are lots of irrelevant characters in the data source, and like the links, emojis, and in our case, our solution only supports the English context. So we also have to filter the non-English word, and also usually software filtering is applied in the natural language processing. But in our case, in order to guarantee the integrity of the sentence, we are not able to apply stop word filtering. And we also design a different, I would say, a different approach called a group series to analyze the evolution of the public opinion. And here's the processed comments, and we can find a very interesting comments here. And these comments is quotes from the videos in which because the blank man was killed by the American policeman, and so after getting the text from the YouTube, it's impossible to input the text into the model directly, we have to transfer the word to the vector, and the word vector to the sentence embedding, and from the sentence embedding to inputting the sentence embedding into the deep learning to make the classification of the user's opinion. And we choose a work-to-vector as our approach of transforming a word to vector. And the idea of word-to-vector then a word meaning is given by the surrounding words which frequently occurs nearby. And based on such rationale, the founder Thomas and his Google team designed the likelihood function, which, as we can see, it has relationship with the conditional probability. And from now we get the word vector. So next step, we're considering to turn the word vector to the sentence embedding. And before talking about the sentence embedding, I would like to give a brief on the transfer learning, because this is a very popular method recently, and also is widely applied in NLP. Just in a word, transfer learning is like the knowledge which I learned from my like teacher or professors. Based on the knowledge which I learned from them, I can apply this knowledge into other fields. This is basically the things that transfer learning will do. And compared with the other popular language model method like LSTM and other GPT and other methods, just combine all of them, we choose two methods from them. The first one is universal sentence encoder, and the second one is I will talk in the later. It's bidirectional representation, encoder representations from transformer. And the main idea of a universal sentence encoder is based on the deep averaging network, which we just need to averaging the word vector on each layer, and the softmax layer would take the final layer's representation Zn as the input for prediction. And this is the second method, BERT, which is a short for what I just said, bidirectional encoder representation from transformer. If I'm allowed to say that the transformer is the backbone of BERT, then the attention mechanism is the core of a transformer. And so starting from the initial stereotype of attention mechanisms, scaled dot product attention, which this formula is designed. So we can see in this formula, Q denotes the current word vector representation, and key denotes the word vector representation or sequence in the sequence. And by such a product, it means that it's trying to calculate the inference of the current word taken on the whole sequence. And this is how the attention mechanism works. And here's the one illustration of how the previous formula works. And the sentence is worth it from word is it, and calculate the sum of the final results. And in BERT, as I said, the previous slide is only the initial type for attention mechanism, but in real case, they apply the multi-header attention. It's just the concatenates multiple attention together and because they found that if they form the attention in this parallel together, then they have the performance can outperform the previous one. And after the previous language model, we get the sentence embedding, and the sentence embedding can be input into the deep learning, and the deep learning will give us the final results as the negative or positive or neutral. And here's our experiment. We have two parts. The first, the evaluation of the model, compare the USME model and also the BERT. And the second part is the trained model being applied on the real case, which is the blank mail security last year in America. And we compared these two models, and we found that just after adjusting the epoch and the rate, we found the accuracies are quite similar, but the speed is not. As you can notice that USC can spend just much more less time than the BERT. And as I mentioned, the group series previously, we also designed the separation mechanism just to analyze the evolution of the public opinion. And here's our results from these two models. And it's quite clear to notice that there's a distinguishable difference between these two models in the positive parts and also the negative parts. And because of the accuracy is quite the close accuracy, so I won't say that BERT is better than the USC, but we have to double check these results in the future. And also there's the summarization of the comments. As we can notice, the praise short, so the larger the word, the more important it is. Here's the reference. Thank you. Any questions?
Thank you, Sue, for your presentation. Dear colleagues, do you have questions? I have not questions because this is my student.
Yeah.
Therefore, I have not questions. Maybe any questions do you have? Okay.
Can I ask?
Yes.
Okay. So you study discussions of videos in YouTube?
Yes.
And have you studied just general topics, or have you concentrated on videos on some specific topics, maybe so that you have the base of how do people generally discuss? Say, maybe it's like gameplay videos and you concentrate on some special topics that appear in the discussion.
You mean how I tried this to apply this model in the summarization of the topic?
I mean, do you intend to analyze any video at all, or concentrate on some specific topics, like gameplay video or, I don't know, musical videos?
Yeah. This model can be applied in any different videos. Like if this model is gonna be applied into the game videos, then it also can like give us the feedback of the public opinion on these the things that the videos are showing, and also the summarization.
Okay, maybe I will rephrase it. Is the process of teaching the neural network topic specific?
The teach we use the trained model. It means that the model is previously is ready, and this is the idea of transfer learning by using the trained model. Then with the parameter that the trained model gives us, we can try to interpret the new field based on the current model.
Okay.
Yeah.
Okay, thank you.
Thank you.
Thank you for interesting presentation.
Yeah. Thank you, Professor.
Maybe let's maybe next.
Yeah.
Presenter.
Yes, if Yang Yifeng is ready. Yeah. Please turn on your mic.
Okay. Hello. Okay. Okay. Hello, Professor. Good afternoon. My name is Yang Wenfeng, and beside of me is my partner. His name is Li Pengyi. Hello, sir. We are undergraduate students from Yan University, School of Mathematics and Computer Science. My major is software engineering. Today, my title is Research on Sentiment Analysis of Network Public Opinion based on BI-LSTM. Next, I will start my report from 4 aspects: introduction, overall design scheme, related key technical experimental result. First of all is introduction. At present, in the information age of universal access to the internet, the number of users on the internet is extremely large, followed by the explosive growth of information. When people visit news or use public social media, they will leave all kinds of comments on the internet. These public expressions of behavior by people at a certain time and place are called public opinion. The trait of public opinion may affect the trait of the belief of the society as a whole and the growth direction of young people. So the trait of public opinion is an important social issue that the government needs to pay attention to. With people's attention, there are more and more studies on sentiment analysis of network public opinion. At present, the methods commonly used in sentiment analysis include sensitive vocabulary method and the support vector machine method. But in sentiment analysis model, BI-LSTM can better capture bidirectional semantic dependency. So our research target is to realize the positive and the negative analysis of online public opinion emotions based on BI-LSTM, so as to assist government departments to judge and manage the tendency of public opinion. Next is overall design scheme. The first is data collection. The public opinion data from the network to download to the local. Then the data is pre-processed, make the data ready for subsequent work. Next is word processing, including word segmentation, stopping words, and so on. Then there is a very important part, training model, including text feature vectorization and the sentiment classification. We will finally get a classification result. This is the overall design scheme. Next is related key technical. There are 3 parts of the key technology: public opinion data collection, data processing, and data modeling. The first is data collection. According to the business needs, the main information of crawling includes user's ID, user's nickname, published time, user's gender, user's preference, user's age, user's published content, and the website of the published content. This information is built into a database table, just like this. On this basis, we choose Scrapy to carry out data crawling. This is an architectural diagram of Scrapy. In this paper, we use directional crawler to initialize the web link. After that, the spider module is started, and the crawling link is delivered to the scheduler via the spider middleware and the engineer. And then the scheduler adds it to the scheduler queue. The scheduler passes the queue header link through the engine to the downloader for download on a first come, first served basis. Stop caller will when queue is empty. When the downloader receives the connection to be called, it makes request and calls the content. When the download is complete, the data is passed to the core. The specific data is then extracted using XPath and Beautiful Soup. After successfully fetching the data, the spider module passes the data through the engine to the Atom Pipelines module, which stores the data in the database. During the causal data, we come to data processing. Because there are a lot of useless data, such as symbols, links, numbers, and letters in the data crowd. It is called noise data here. Noise data is meaningless in data analysis, so it needs to be pre-processed. The regular expression code is simple, and the processing speed is fast, and it will complete the work of capturing the string. So the method of regular expression is adopted here to extract the data. Word segmentation. The premise of text content analysis is to carry out word segmentation operation on the text. We use the precise model of JBA word segmentation to carry out text segmentation. Sentences can be segmented as accurately as possible. Dealing with new words, we can use the API provided by the JBA word segmentation system to write the hot words and new words and their weights into the file so that the system can currently identify the words. When processing stop words, we can also use the API provided by the JBA word segmentation system. Select the.
Oh, sorry, Young Van Feng. It is the time is over. Am I right or not?
I don't think so.
Sorry, Professor. Is my time done?
No, I think it's just 8 minutes.
Okay, yes. Sorry, yeah, you can continue.
Oh, yeah, I mean, I just speak. Okay, I continue.
Yes, you can continue.
Wait a minute.
Share screen, please.
Sorry, wait a minute. Okay. Let me begin. Okay. We're dealing with the we're processing stop words. We can also use the API provided by the JBA word segmentation system. Select the appropriate stop word dictionary and write the relative path of the file. After the above steps, we get the appropriate data. The next step is emotion analysis. In order to be able to process text using the BI-LSTM, text data needs to be transformed into text feature vectors. We use doc-to-name model to vectorize text features. Because the BI-LSTM model already takes into account the semantic relationships of context, doc-to-name only needs to number all the words. Doc-to-name will pre-count words frequency, nx, and then set the word frequency threshold, y. For words with nx less than y, it means that the accuracy of the word is too few and has little influence on the final result, so it can be removed. The remaining words. Finally, replace the words in the text with numbers. From now on, the vectorization of text features is completed. Next is sentiment classification. First, the model is trained and testing using the training data by LSTM. We can get a better sentiment classification model based on by LSTM. After that, the data crawled by the caller will be pre-processed, and pre-processed data will be imported into doc-to-name to generate the word vector model. Then the word vector is input into the trained classifier to make emotion prediction, and the prediction result can be obtained. Here, two results are present. One is result of prediction of piece of text, which is positive or negative. The other is probability of occurrence of the prediction. The two results are then stored in the new field in the original database. This table is database table. You can see that there are two more fields, PAN and PRO. Next is experimental result. From this table, you can easily see that for each column, the system automatically gives a predicted value, PN value, and so gives the probability of the accuracy of the prediction. Through training, the emotion classification model is established, and the Scrappy crawler framework, Java word segmentation system, doc-to-name model, and the BI-LSTM model are mainly applied. It mainly realizes the analysis of sentiment classification of public opinion information. This paper analyzes the correlation between the above framework and model, discusses the specific implementation process and the core technology, and finally expounds the result of public opinion analysis. After a lot of data training, this model can give better and high precision analysis results. Through this, our target of assisting government departments to judge and manage public opinion tendency has been realized. Okay, that's all my presentation. Thanks for every professor's correction.
Thank you very much for interesting presentation. I have a question. Did you train your model on Chinese language? Yes.
Yeah, I use
only Chinese language.
Only Chinese language, yeah, because Chinese language and English language have difference with the blank between the words and words. Chinese, yeah, Chinese have no blank, so it's more difficult.
Okay, thank you. Thank you for your answer. Dear colleagues, any questions? Okay, thank you very much.
Thank you, Professor.
The next presentation is recommendation system. Yes.
A movie recommendation.
Zhao.
Okay, can you hear me?
Yes.
Yes. Share full screen, please.
Okay. Can I start or just wait to 5th clock? 7th clock.
Zhao Qi, please share full screen.
Okay.
Mm-hmm.
Good afternoon, Professor. My name is George Shi, and my supervisor is Ivan Blinov. Today I'm going to talk about two-tower collaborative filtering algorithm for movie recommendation. Okay. First, I will introduce the background, and next I will introduce the definition of recommendation system and some related work and the dataset I used in the research. And part 3 will show the original data realization, and part 4 will show the architecture of some models. And finally, I will show some experimental result and the conclusion and the future work. We are in the information overloaded area. So how to extract valuable information in a quickly and efficient way is has become an urgent task for people. So we need a recommendation system. And the recommendation system is very useful for both user and item makers. For users, recommendation system can help them to obtain interesting information in a more efficient way. And for item makers, they can use recommendation system to improve the user stickiness and the conversion rate of users. This part, I will introduce the recommendation system. Recommendation system is a type of application that determines the item or service that user needs or is interested in, based on users' historical behavior and the context information. Formula definition of recommendation system. For user U in a particular context C, construct a function FUIC for a large amount of item information, which predicts the user preference for a particular candidate item I. Then sort all candidates according to their preference to generate a recommendation list. This figure 1 shows a logical architecture of recommendation system. We have the candidate items. We can consider this part as all items in our database, and we have historical behavior like users, items, and the users action to items in a particular context, and we can use this part. We can use this data to train our model and training our recommendation system, and from the candidate items to generate the recommendation list. And generally speaking, in 1992, scholars in Minnesota, they proposed the traditional collaborative filtering algorithm, and 2 years after 2 years later, and they also developed a formal model for the recommendation problem. And there is a famous prize, which is called Netflix prize. In 2009, the matrix factorization model was won the Netflix prize. And there are also many scholars. They implemented the deep learning version of matrix factorization model. And in 2017, some scholars at NUS, they proposed the neural collaborative filtering algorithm. And in 2019, YouTube team proposed the idea of the two-tower model for large corpus item recommendation. In our research, we make the combination of traditional collaborative filtering algorithm with matrix factorization algorithm, and based on the neural collaborative filtering model and the YouTube two-tower architecture, we propose a new architecture of model we called the two-tower neural collaborative filtering model. The dataset we use is a movie length dataset. The dataset has the three files: links file, movies file, and the rating file. I also make some extension for this original dataset, and all code is uploaded to GitHub. We can see the link, but in this presentation, this is not all point, so I just mentioned this part. This is a original data in a dataset. And this part is data visualization. Figure 5a shows the user gender, the proportion of user gender and the user occupation. And this is a distribution of users age group. This part is the distribution of users. No, it's users location. It's a mistake. This part is the density, the United States, the density, the population density of United States, and the distribution of users location. And this part I will introduce some traditional algorithm. The first one is traditional collaborative filtering algorithm. First, we need to construct a co-occurrence matrix. The row represent users, and the column represent atoms. We need to calculate the similarity between them. Equation 1 shows how to calculate constant similarity. In traditional collaborative filtering algorithm, we can consider the row as users embedding the users vector and the column as atoms vector. Then calculate the similarity. We can get the rating, the users rating to the atoms. And this is a matrix factorization algorithm. They consider the co-occurrence rating matrix as two lower rank multiplication of matrix R equal to P times Q transpose. This is an illustration of matrix factorization model. And this figure 11 shows the architecture of deep learning matrix factorization model. In the input layer, we just use user ID or use atom ID, then training the embedding layer. After embedding layer to get the users vector and the atoms vector, then just do an inner product to calculate to predict the score. And this neural self model add some hidden layer in the inner product. In our research, we use neural collaborative filtering model as our baseline. This part is YouTube two-tower architecture. They consider users and the atoms as two separate parts and handle them respectively. this part is the figure 14. A shows the neural self model, and B shows the two-tower neural self model. Two-tower neural self model what was proposed by ourselves. This part shows how our model works. Denote xi and yi as the set of users and atoms, and xi belong to x and yj belong to y, both mixture feature vector of users and atoms. They can be surprise feature and the density features, could be a very high dimensional space. X and Y are both vector space in their corresponding dimension. We aim to build a model with two parameterized embedding function. U map X to RK and V map Y to RK. In this article, the default input vector are all column vector. Then there exists input embedding matrix W and output embedding matrix W dash for users, same as atom embedding matrix. Denote input and output embedding matrix of atoms as Wi and Wi transport and Ws dash respectively. The last layer is the inner product of these two functions, U and V, and the output of the model was the rating. We need to calculate the rating from user to atoms. The Rxy equal to W times Sxy plus B. W is just a scalar and B is a constant. And the goal of our model is to learn these four metrics W, W dash, Wi, and Wi dash from a training data set of T examples. Like equation 5. And xi, y is the pair of user xi and the movie y. And ri is the corresponding interactive behavior for each pair. We use MSE as our loss function, as shown in formula 6. And we can use some optimizer to fit our model. In our model, we use atom optimizer rather than gradient descent. This part is show how the atom optimizer works. It's not our point, so just mention. This part show the detail of our model. The weighted matrices are initial randomly, and for user tower we have the equations 8, and for atom tower we have equations 9, and finally we calculate the dot product of U and I, and just a linear function are equal to Ws plus B, and using ReLU function to remove all negative values. Then we can summarize our algorithm. Input is feature vectors of a user and atom, or a batch of users and atoms, and repeat. Receive training data, forward propagation, and compute the loss function, update parameters by back propagation until the stopping criterion. Generally, we use root mean square error to evaluate our model. This part shows the experiment result. We test our model on movie length 100 kilo and movie length 1 million. The baseline is neuroself model. The RMSE is equal to 0.961, and training this model costs 509 seconds, and we can see our model perform well in both data set, and the cost is also better than the neuroself model. And the conclusion, two-tower neuroself model works better than neuroself model on both data set. And after the training procedure, we can obtain the embedding matrix of users and atoms. Just do a matrix multiplication, we would find the similarity matrix, user to user, atom to atom, and user to atom. And the final step of our research is to generate a recommendation list for users based on the similarity matrix. Actually, this part I have complete. I can show you the network. This part. This is a final result of my model. I generate actually I generate 4 network. User to user, movie to movie, user to movie, and the whole network. Whole network is the combination of the first 3 network. We can deep more in the last network. This is user 350. We can see the connection of this user. Some connection movie and some connection are users, and we can see the connection between them to deep more about this network. Okay, this is user to movie network, and this is just a result. Okay, here is reference. Okay, I'm ready for answer questions. Thank you, Professor.
Thank you very much for your presentation. It's very interesting. Do you have any questions, dear colleagues? Colleagues?
Yeah, no questions. So.
Okay. Okay, thank you very much, Xizhao.
Okay, thank you, Professor.
And we have last presentation.
But I cannot see the speaker in the conference right now.
Speaker is absent, yeah?
At least we don't see him or her here, and we have no idea how to contact.
We can wait 2 minutes.
Yeah,
and close
2 minutes. All right, in 2 minutes, Alexander says the finishing word.
Alexei, do you know last presenters is our student or not?
Actually, I have no idea.
Okay.
I only have the official program, unfortunately.
thank you everyone for a great session. I think this year there are a lot of participants, not only from St. Petersburg State University, but also from other universities.
Avanas, sorry, we can hear you very, very silently.
I think the session was very great. Thank you, everyone. This year, even we have a participants from Karlsruhe Institute of Technology, from from ISO,
yes.
Yan University. I think this is very great. Actually, as far as I know, there are not a lot of conferences that are somehow open for the students. Not all around the world, there are not a lot of this kind of conferences. So actually, we are providing a great platform. I think this is very great. Thank you very much. Great experience.
Thank you, Professor Petrosyan. I think that our chair, Alexander Krylatov, can say his conclusion remarks.
Yes, thank you very much, Dr. Yeremin. Unfortunately, it was hard task to understand Dr. Petrosyan because it was very some problems with sound. Anyway, let me conclude our section. I guess it was very interesting experience for all of us, and as Dr. Blekanov have already mentioned in our messaging, that this year the papers of students, the quality of papers of students were higher than previous year, and we hope next year we see papers from Yan'an University, from ISO University, from Karlsruhe University. Maybe we can also ask our colleagues from Finland and from France to participate in this conference, since this conference become international, indeed international, because you know that for a long period of time some special universities participate in this conference, but it was not permanent event. But according to the current program of the conference, we have a big list of foreign participants, not from only one university, but from 3 universities, as far as I understood. This year it were 3 universities, and we have lots of different and interesting, very interesting topics and methods, and I hope that this collaboration, this cooperation eventually create very interesting common results, and maybe this conference become or not become, but get higher level. Maybe one day we will have Scopus indexing or Web of Science indexing of proceedings of our conference. I believe it because I think that today we have a very good and high level of results that presented at this conference, and we know that some young conference or conferences for young scientists have this opportunity to publish papers in proceedings that are indexed by worldwide systems like Scopus and Web of Science. And I believe that together we can make this great step. So thank you very much for your presentations, for your hard work and your scientific results. I believe you will have success in your professional and scientific dealing with different real challenges. So I hope this year will be much better than previous one. And I want to say have a good year and have a good time doing your research. Thank you very much.
Thank you. Thank you, colleagues
Professor.
and participants. Thank you.
Thank you. Bye-bye.
Yeah, thank you, everyone. Alina, I think we can finish that broadcast.
Okay.
Oh.
Alexei,